Hey everyone, welcome to the second Azure Cosmos DB Conf. I'm Stephanie and I'm here with Deborah. So Cosmos DB Conf is an online event comprised of 3-hour live streams across the Americas, Asia Pacific, and EMEA regions, as well as entire track of sessions available live on demand. Azure Cosmos DB Conf was organized to provide a stage for Cosmos DB customers and the community to share their knowledge and discover each other. So each of these live streams includes content created by the local members of the Cosmos DB community. And then if you miss any of the live sessions, don't need to worry. These will be available on demand right after each of the sessions conclude. So viewers watching via the Microsoft Learn TV are able to ask questions on our moderated forum. So if you have any questions, make sure to drop those there in the Learn TV chat.
Cool. So over the next 20 hours, we'll see and hear from customers who have built amazing applications using Cosmos DB in the cloud. They'll show you what they've done, their lessons learned, what you can learn as well. Really excited to have them all today. For those of you following along at home, you can tag your posts with hashtag Azure Cosmos DB Conf about the conference or your thoughts on social media. So let's kick it off by introducing Scott Hanselman, looking to our customers today. Scott, thanks for being such a great friend for Cosmos DB, and welcome to the show.
Absolutely my pleasure. Yeah, it's going to be fun. We're going to talk to some cool customers who've been using Cosmos DB. For folks who've watched me on Azure Friday at azurefriday.com, you know that we have our friends from Cosmos on all the time, and the opportunity to come to Cosmos DB Conf and talk to real engineers working on real stuff and real customers was one I just couldn't pass up. So thanks for having me. All right, so what we're going to do is we're going to bring on Natasha Diaz-Over from Walgreens. She's a technical architect at Walgreens. Natasha, welcome to Cosmos DB Conf. How are you?
I'm good. Hi, Scott. I'm pretty good. How are you?
Yeah, thanks for hanging out. Like I was saying before, I really love having folks that are working on real things come and chat with us today, and that's why we're having you here today. So what did you all build with Azure Cosmos DB?
So at Walgreens, we're actually currently in the process of building a new pharmacy system for our stores, and we're calling it RX Renewal. So our current system is about 30 years old, and yes, it was ahead for its time, but it's now due for an upgrade. With RX Renewal, what we've done is we've gone down the path of building microservices. So it's a domain-based development where domains are grouped together by products. In our legacy system, upgrades were really delivered as a single package, which contained all the components. So let's say we needed to make a clinical change, to the program. We were still deploying the billing components as well, simply because it was packaged together. This, of course, was a lot of downtime. And what we've done with Cosmos DB now is gone a more focused level with microservices. So if billing needs a fix, then the patch really touches only the billing functions and the billing database, no more impacting other processes. So that's really how we're using Cosmos DB.
Okay, so it sounds like the shift to microservices probably provided a lot of business value. Well, what is the specific business value that you provided to the company?
So our pharmacists are really now working with an interface that is more modern. It's internet-based, so it's more natural to them. In our legacy model, what we had was separate store servers and a central server. So the information needed to be sent from our stores back up to the central system. So stores operated only in a store-only or a central-only fashion. With Cosmos DB, everything is now cloud-based, so it's all centrally located, and we don't really have to transmit data back and forth. Because it's cloud, it also means higher availability, and so less downtime for maintenance. And that translates to a much better customer experience.
Mm-hmm. Now you're new to Cosmos DB. What was your experience? What are some things maybe that you learned during this development process?
So I've worked with databases for a really long time, but it was primarily with on-prem and cloud. And Cosmos DB was my first exposure to a PaaS system. It was a completely new experience to no longer have to keep track of what software versions we were at, what was supported, when we needed to upgrade, what changed between versions. This whole building and maintaining of database software was gone. And of course, the licensing costs went along with it. I want to say another big change for me was also the business continuity planning. Yes, I still need to plan for it, but I'm no longer writing backup scripts, maintaining them, or having to work with backup teams to check on them to see how fast my backups are completing. Are they completing on time? Can I restore them? This has all now been passed on to Microsoft, and the team is really more focused now on application design. I want to say I also really like the high availability setup. My data is now really replicated 4 ways with availability zones just through the click of a button. And DR testing is so much easier. Before, we had to have multiple teams coming together, in a room, planning, testing. Sometimes it took days. Today, for the database portion of it, we're testing in minutes as opposed to days. So while, yes, originally there was like a really steep learning curve, on the whole, I think I really had a good experience, moving from IaaS to PaaS. So,
Was there anything particular that was really surprising? They were just like, wow, that was a surprise.
cost and how much detail is being provided. So before, for our projects, what we used was a bucket system. So we would just dump all the costs into a singular bucket and break them up, divvy them up, and distribute them to the projects. So basically, projects were getting what was considered a percentage of that bucket. Now we're seeing costs broken down by hardware, network, database. And so we can provide our business really with an exact bill. When we're talking of cost, I guess we can even say that with Cosmos DB, we're able to spin up environments so much faster, like in hours instead of days or weeks, because those resources are easily available to us. We can tell the business that, if you shut these services down because they're not in use at the moment, this is your cost savings. Or if you want to grow, this is how much you can expect to grow. For me, I think more importantly, I can actually show the impact of database design on the cost. If your workload is really unknown, you can use autoscale. You observe, then you make the change. If I make a mistake and I provision something incorrectly, I can fix it. And the cost impact is seen immediately. I'm not stuck with that cost because I made a mistake. Bad queries, if developers write bad queries, it's now actually defined in terms of dollars. So I can send them back for tuning. So these really fine-grained cost details were an unexpected bonus for us.
As we get towards the end of our little chat right here, I'm curious if there's anything that you'd like to see improve, right? It's not just gushing about all the wonderful things about Cosmos. There must be some things that you'd like changed.
Yes, I come from a DBA background. So for me, I'd like to see a selection of tools and utilities that allows me to analyze the environments better. Yes, I know Cosmos DB was really built for developers, but the business really always wants good, fast, inexpensive design. So if there were tools that allowed me, quick analysis, that would really be helpful, like a script that goes through the accounts and picks indexes that have the default settings still, or collections with RUs that are too high, so I can revisit them and see if anything needs to change. Yes, I know advisor recommendations is a feature that is out now. As we see ourselves rolling out to more and more stores, I'm really looking forward to see what that provides.
Fantastic. Well, thank you so much, Natasha Diaz over, technical architect at Walgreens, for sharing all the great stuff that you're building on Azure Cosmos DB. Very interesting stuff. I like to see what practitioners are doing with the product. Now, my second guest is Brandy Umdenstock, Senior Software Engineering Manager at Sam's Club. Hi, Brandy.
Hey, Scott.
So what did you build at Sam's Club with Azure Cosmos DB?
Yeah, so we actually built 2 systems on Azure Cosmos within Sam's Club, or within my team anyway. So the first one that we built was our core membership platform. And that's the transactional backend system where all operations interacting with membership data take place. Those interactions happen across multiple channels. So in club, across 600 clubs in our chain, through our e-commerce platform and on our mobile app. Some examples of those transactions, and this is by no means an all-inclusive list, but just some common examples of things that people do with this platform are membership joins. So the new membership creations, membership upgrades, renewals, membership validations at checkout, and account maintenance activities like email or shipping address updates.
Wow, that sounds like a pretty significant thing.
Yeah, it's definitely a core platform for running the Sam's Club business.
Wow. So that provides a lot of like business value. Like you did it one way before, and now bringing Cosmos into the mix made things better for everyone.
Yeah, absolutely. So the membership platform, as well as the credit platform that I didn't quite get a chance to explain, they were the two things that we built on top of Cosmos, and they were existing systems before. They were running in a legacy environment because they had been built many years ago, and so we actually migrated these systems from the legacy platform to Azure and Cosmos. So in doing so, we were able to realize a handful of benefits. Some of those are just the ability to scale to meet our business needs. We were able to consolidate our data into a single golden source for both membership and credit. We were able to reduce cost, complexity, and time in delivering business initiatives. And also, this move provided business continuity and disaster recovery capabilities for us that were not necessarily there before.
Wow, that really speaks to the platform as a service idea. Like you just got stuff, for free because of the underlying platform. So it sounds like you learned a lot during this development process.
Oh, absolutely. So we were actually one of the first teams in our organization to begin experimenting with Cosmos. So we really didn't have a lot of context or a baseline to really even know what to expect, especially in terms of performance. So one of the things that we really learned was that Cosmos provided better performance than we had originally anticipated. For example, when we were working on our integrations at point of sale, we had a goal that the new system needed to perform as fast or faster than the existing system. And when we were done with it and all of our performance tuning, we actually cut the overall transaction times at point of sale in half from where we were with our legacy system, which was actually very fast itself. So that was something that was really cool that we learned. We also learned just around just some things in general from moving from a relational database to Cosmos. We learned quite a bit about database structure design, query optimization. We had a lot of tests and learning in that process, but we were able to design database models based on our business use cases and ensuring the right partition keys were defined so that we could spread out the data evenly across the partitions and optimize the designs of our queries.
Was there one thing that stood out that was the most surprising thing during this process?
Ooh, I'd say, one thing that was very surprising to us was the point read query performance. So we're a very heavy read system. And in the point reads, we see single digit millisecond performance about 99% of the time. Our business use cases that utilize those point reads had about a 50 to 70% performance improvement versus our legacy system utilizing that point read capability. So that was pretty surprising for us.
Yeah, I am when I have Kirill and from friends from the team on my show Azure Friday, I'm consistently surprised when things are single milliseconds. Like it's like that's not possible. But the idea that you're seeing that in 99% of your reads is really truly amazing. So do you have any feedback for the team that you want to share in a live forum at the end here?
Yeah, I think I would just call out that we have been very impressed with our system's ability to scale and handle high throughput. We've run our last 2 holidays at Sam's Club through Cosmos, also multiple PS5 and Xbox events, and even the COVID panic buying frenzy that happened a few years ago. All of that ran on Cosmos, and we had very dynamic throughput during all of those occasions, and the system handled it without any issue. So we've been very pleased with the product.
That's fantastic. Well, thanks so much for sharing some real stories about what you're doing over there at Sam's Club.
Yeah, thank you so much.
All right. That was Brandy Umdenstock, Senior Software Engineering Manager at Sam's Club. My next guest is Guillermo Rauch, CEO and founder of Vercel. Hey, how are you?
How's it going? Good to see you again, Scott.
Good to see you, sir. It's been a little while. Everybody online's talking about serverless, and I like to joke that there's still servers. You just think about them less, right? And what was so appealing about the first part of the cloud, and why did it get people excited? And how did we get into serverless?
Yeah, I think you teed it up really well. I think it's always been around hiding complexity and just leaving complexity behind. I think Cloud 1.0 is about leaving that data center behind. I think we could have called it data center less back then. We didn't, but people would have said, "Oh yeah, the data centers are still there. You're just not thinking about it. You're not maintaining them." And I think when it comes down to the specifics that relate to data distribution, I think the thing that stood out is like it's just about making cloud possible. It's just about, okay, putting some software in a box, in a virtual machine, software likely that already existed and was not exploiting the primitives of cloud just yet. And it was single region, and it was all about just making things possible and affordable for people to get online and worry less about that underlying infrastructure.
That is really, like, you just gave me like a moment, when you're listening to a podcast and you're parked in your driveway, but you need to get out of the car, but you want to keep listening because that was a moment. So the first part of the cloud was just proving that we could put computers in a box and think about them less. Okay, so once we
Yes.
proved that out, we're like, okay, we can put them in a box, we can cool them, we can do things, we can bill per second, right? So then how
Yes.
did that evolve to platform as a service and then just really functions in the cloud?
Yeah, I think that's what's interesting about serverless is that I think it's what really takes advantage of the cloud as a whole. You mentioned the pricing model being unique to the consumption of the service. It allows you to engineer differently in my mind because now I'm thinking, well, according to how I structure my code and my data, I'm being billed only for what I use. So when it came down to storage, I think things like S3 and the innovations that started to come with cloud, which were hiding some of the operating system implementation details and were giving you altogether new interfaces. Whereas a developer, you're just reasoning more about the application layer of things. And I think really that's what serverless truly is about, which is about thinking more about your application, less about the underlying infrastructure, and then kind of getting those developer experience benefits, especially what we do at Vercel around, well, you just put your application in the right framework, in the right shape, and then it just seamlessly scales according to traffic and usage.
Now, I've seen people say that they shouldn't have to think about the cloud, but when we also hear the word cloud native, which means that we're thinking deeply about the cloud, we initially naively lifted and shifted. We picked up stuff and we put it in the box in the data center, but applications are better when they know what's underneath them. How do you see modern applications that are being built with Next.js? Like, do they know that the cloud is there, or do they just ask for functions and everything's magic? How much awareness of the cloud is in the app layer?
I think there has to be to a certain extent, right? Because you want to take advantage of as much cloud as you can. And I think the final transition from Cloud 1.0 to serverless is to edge computing. And now we're starting to involve location, especially with data platforms like Cosmos, which are truly global. We're going from region to applications that are globally distributed and are fast everywhere in the world. So one of the things that Next.js helps customers do is put the application in the right shape and use the right primitives for each part of the life cycle of the application. So for example, when a request comes in, I can first handle it at the edge. I can do some of the rendering there to personalize the experience. But then there's other parts that I have to run right next to where my data lives, and I can use serverless functions for that. So Next.js is all about enabling this cloud native developer model, hiding all the parts that are truly boring and unnecessary, but rising those elements that are going to make your application distinctly unique. And in this case, global.
Yeah, I like that because that is the whole point of computers, right? Is to hide the boring stuff. If you can do something twice, then you automate it. And if it's boring, let the computer do it. That seems like a reasonable thing
Brilliant.
to focus on. Now, you mentioned that it's about the edge and getting closer and closer to the end user. Cosmos already, in some cases, has, as we've seen, single-digit millisecond responses. Vercel really prides itself on being warm, hot, fast. As long as I've known you, you've been obsessed with
Yeah.
making things happen. If it's already single millisecond and you bring it to the edge, you're talking about instantaneous applications, is what I'm hearing you
Yes.
say.
Yeah, one of the examples of combining Cosmos and Next.js is Walmart, where they were making transactions from the UI, wherever the user is, in the multi-master Cosmos setup. So it's not even just reads, it's also writes and right next to the user. I think that is the full premise of edge computing, is that no matter where the visitor is, you're delivering the application to them. But unlike old style CDNs, we're not just giving them the static assets, the videos, the photos. We're giving them the full dynamic application experience right where they are. That could involve giving them content that suits their location, giving them the right discounts, the right prices, the right searches, the right suggestions. But then when they're transacting, I think this is a feature that's quite unique to Cosmos as a data platform, is that you're also giving them really snappy response times. One of the things that we pride ourselves in with Next.js is that React allows us to put compute everywhere. We do it at build time with static generation. We do it in the core regions where your data is with server-side rendering. We allow you to personalize at the edge with edge rendering. But then what's really cool about a React app is the interactivity on the device itself. So the key thing there is that I want to tap, I want to see my card animate, and then I want that card to be safely stored in my database. And this is where these global data platforms, in concert with platforms for the front end like Vercel and Next.js, kind of like give you that global maxima. It's just fast all across the board.
I don't know if you may be old enough to remember the commercial where the guy with a jar of peanut butter bumps into the lady with the chocolate, and then they throw it up in the air, and then suddenly they go, "You got your peanut butter in my chocolate." It seems like the mix of Next.js
I love
and a global data platform like Cosmos DB is a great peanut butter and chocolate type of situation.
Absolutely.
All right. Absolutely brilliant. So lovely to see you. And folks can see you, of course, online and check you out at Vercel and learn more about Next.js and how it works great with Cosmos DB. Good to see you.
Thank you, Scott. See you.
All right. Those were some really great stories from customers using Cosmos DB in the real world in their businesses. But next, we're going to bring out architect Kirill Gavriluk to talk about what's in the future for Cosmos DB. Kirill.
Hi, Scott. Great to be
How's
here.
it going?
Good,
So Guillermo, always thinking about these things from an architectural perspective, trying to get things, sub millisecond, fast. He talked about the future of serverless. What is the future of serverless for databases? Is this a solved problem? Is there anywhere for the Cosmos to go?
Oh, I think we're only getting started. I mean, really, when customers looking for serverless from the database, they're looking for three things: no servers, or not think about servers, as they really don't want the database as a service. They want data API as a service. And I think we're getting there. Second is they really want to pay for what they use, as Guillermo pointed out, and they really mean it. It has to pay for what you use, only those transactions, and pay nothing when there are no transactions, and at any transaction rate. And that's where I think with Cosmos platforms like Cosmos DB, we can give you that at both scales. When you just have few requests and we charge you per request at some like 25 cents per million requests, or when you have lots of requests, millions of transactions per second, and we only charge you when you actually do them. And quickly, we don't really need to scale anything. We just you just pay for what you use. And most
it definitely seems like, from what Guillermo was saying, that is the expectation. I mean, the folks at Sam's Club love it. The folks at Walgreens love it. We want instant reads. We want instant writes. We want them as close to the user as possible. We only want to pay for what we use, which is super, super important. When you come on Azure Friday, when you come on regularly, you are always showing us something new. It seems like there's new things happening in Cosmos every quarter. What is the team focused on in the short term and then in the next, 6 to 9 months?
Absolutely. In the short term, a lot of our focus is on our strengths. I really believe that as you invest in your strengths, you can get only better. And so elasticity and serverless, because that is the future. And so we're announcing it's built quite a few exciting things around kind of expanding our serverless footprint, as well as offering folks platforms where you pay even less, and it's a lot more efficient and a lot more tuned to exactly what you use. So you don't have to worry anymore about hot partition keys and nonsense like this. A lot of investment is in availability. And kind of looking and the developer experience, right? I was always about it's my pet peeve, but it's very important. The platform used to be super simple to use, and kind of Cosmos DB solves really complex problems, and you don't don't want that complexity to transpire. Going forward, though, I think we're seeing three trends. It's a very exciting time for databases. You're seeing NoSQL and relational coming from opponents to friends and more. We're seeing non-relational platforms adding more richness to query, better ACID guarantees, etc. We're seeing relational platforms adding horizontal scale, and Cosmos DB is like very uniquely placed, where at the foundation it is not religious. There's nothing particularly NoSQL about it. So we're definitely tuned into that trend, and you should see some exciting stuff coming out of Cosmos DB on that front. Serverless is definitely like we'll continue pushing on that, and then really kind of providing developers intuitive APIs is very critical to us. We want to have fewer APIs, and we want to focus on the APIs, but things like React applications love GraphQL.
Mm-hmm.
Believes that all databases should have GraphQL endpoints. And things like that.
So there's a very famous, I think it's Arthur C. Clarke, who's a science fiction writer, who said any sufficiently advanced technology is indistinguishable from magic. If you have something super advanced like Cosmos, you're like, I don't know, it's magic. Now, each additional layer of abstraction in computer science is indistinguishable from magic. Now, when I work with Cosmos, I tend to use the Mongo or the Graph, I use the Gremlin, I use different APIs. Cosmos is one of the few examples of a successful multi-API offering. It seems indistinguishable from magic, but sometimes it can make things more complex. What is your view kind of on multi-APIs, and are you going to add more? Because it's magical to think Mongo and store in Cosmos.
It's been certainly one of the bets that was surprisingly successful. We were a bit skeptical at the beginning, because the promise of multi-API is that you provide consistent experience. I can set up backup policies across all my databases, whether they're Mongo or Cassandra, because it's the same platform. I don't need to think about how to set up high availability and things like this. But you're right, it brings complexity. I think we certainly have 3 very successful APIs on the platform. Our core SQL API, Mongo API, that is very popular. Cassandra API that brings us petabytes of data into the platform. I think we're gonna be very intentional adding more, because that adds complexity. We're gonna focus, and focus is a virtue, on making those APIs even better and better. We may add, as like in response to the trends that I just mentioned earlier, around kind of the relational and non-relational coming together. There's some exciting stuff will come out, but we'll be very diligent and focused on like how many APIs we want to add.
Very cool. Well, it's always fun to have you on and chatting with me. If you can check out more Kirill at AzureFriday.com. There's tons of great content, documentation, and videos with our friends from the Cosmos DB team. This has been wonderful, Kirill. Thanks for letting me join you all here on Cosmos DB Conf. We talk with Walgreens, we talk with Sam's Club, we talk with Guillermo from Vercel. Fantastic. I hope you have a wonderful, wonderful day, and we'll bring back Steph and Deb to share the rest of the day. All right. That was pretty cool. Hey, friends. I got to meet great people doing great stuff at Walgreens and Sam's Club, and talk to Guillermo from Vercel working on Next.js. I know that you have a bunch of cool things that are coming up in the next segment, right?
Yeah, so many great presentations that we have and demos. I'm so excited to see the rest of the day. And thank you for asking all these really great questions and speaking to the host. I had a lot of fun with you guys' conversation.
Thank you so much, Scott.
All right, so in the next session, we'll be hearing from a few speakers and how they've used Cosmos DB to build an app for patients with diabetes, and how they've developed using the Linux emulator, and how to migrate using applications onto Cosmos DB. So yeah, on to you, Deborah.
Thanks, Steph. Yeah, I just want to say before we move on, my favorite part of just the whole keynote was just seeing all the amazing real-world scenarios that I could really relate to. And as someone who works on the product, it's really awesome to see it being used in the real world and having an impact there. So on that theme, our next speakers will be Dr. Alok Kunungo, Chief Diabetologist and Chairman at Kids Hospital, joined by Vikram Ray, solution architect at rxfund.net, who will be telling us how they built an application on Cosmos DB to help patients with diabetes.
Thank you. Welcome. Hi, Vikram. Start for a few minutes, then I'll join.
Sure. I'm audible?
Yes.
Hi, all. Actually, we heard a lot about Cosmos DB. It is an amazing and magical product. And that actually led us to use for diabetics because as you all know, diabetic is the #1 killer disease. And with COVID, it made it difficult to take care of diabetic peoples because of the close downs. So that made us to develop application for the diabetics people for global solution because diabetic is a global problem, a disease. So that's why Dr. Alok Kanungo helped us, or actually we help. We work together to come up this Nimai Cosmos DB based application for the diabetic patients for Alok Kanungo's diabetic specialist hospital. So you can start, Alok. So then I'll follow from you. Yeah.
Right.
You want me to share my screen or?
No, I'm sharing. Can you see?
Yes, yeah.
So, dear friends, I'm happy to share this platform with you, with these internationally reputed technocrats, and Vikram and me understanding very well about the problems of diabetes. We thought of giving a little betterment in life to those millions of diabetics and their family members. And as you know, diabetes is a chronic disease which occurs when the pancreas does not produce enough insulin or when the body cannot effectively use the insulin it produces. This leads to an increased concentration of glucose in the blood, or called as hyperglycemia. There are type 1 diabetes, type 2 diabetes, and diabetes in pregnancy. And diabetes is not a glucose disease alone, not a sugar disease alone. It is noted for its complications like stroke, heart attack, peripheral artery disease, diabetic retinopathy, cataract, glaucoma, diabetic foot, diabetic nephropathy, and peripheral neuropathy, where patients suffer a lot. Diabetes is the 4th leading cause of global death by all causes. Up to 80% of type 2 diabetes is preventable by diet and physical activity. And before the insulin was discovered, the diagnosis of diabetes was coming with a death certificate within 6 months. This child in the center, you find Johnson, was given the first dose of insulin, and after 2 months, you find his health has improved so well. So 1921, Banting and Best changed the way we were looking at diabetes. As I told, retinopathy, coronary artery heart disease, nephropathy, peripheral vascular disease, and neuropathy are one of the most common problems of diabetes. And number of people with diabetes worldwide and for IDF reason is increasing. And there is a projection that now it is 2022, by 2045, the people within 20 to 79 years will be doubled, tripled in the world, and the number will be phenomenal. And these countries where you find these countries with these marks are Africa. The IDF has divided it into different regions like South and Central America, Africa, Middle East and North Africa, and Southeast Asia. And the numbers are going to be very high in Southeast Asia. If the current trends continue, 700 million adults will have diabetes by 2045. The largest increase will take place where economies are moving from low to middle income status. This is a very important point to note. As you can see, the diabetes in children or type 1 diabetes is increasing hugely in Europe and other countries. And in few time, it will be more. But in Southeast Asia, the International Diabetes Federation postulation or study is that from between the age of 35 to 75, the number of, or even 80, number of diabetics are increasing very heavily. And in India is also 9 to 10% population are affected, whereas in Bangladesh and some other countries, Ceylon, it is more than 10%. So in every part of the world, this is increasing. And in poor countries, people with diabetes have to bear the entire cost of their treatment. And in India, more than 25% of income is spent to avoid fatally high blood glucose level. And that is the pinch we are feeling. And what is if nothing is done to control this pandemic? Threat to subvert the economic gain globally, stress on government budget like disability, pension, medical service, cost, revenue, etc. More problematic situation in developing countries than in the developed countries. So as you know, medically we are learned that diabetes management depends on diet, drugs, exercise, education and social support. This is very important, where Bikram is playing an important role. He is providing social support to diabetes families, and we are trying to make the life better of those families. Family income is reduced by diabetes, more time is spent in care of diabetes, fear and experience of disability and premature death are very few things. When a system is not working for patients, trying harder will not work. Only changing the care system or our approach to care will work. And that has led to this problem of creating an app about which Bikram will talk in loud. Because in India and other Asian countries, there is no access to health care and people can't reach, but everybody has a telephone, mobile phone. So we are developing an app where there will be much more benefit to a patient, and it will connect the isolated patient to the national or state level healthcare system. Thank you, Vikram. This is your time now.
Okay, thank you, Alok. So I'll share my screen.
I'll just go out.
Okay. Okay. You can see my screen? Hello? Oh, I can. You can see my screen? Hello?
Yes, we can see your screen.
Okay, so I'll present. Okay, so as Dr. Kanungo said, this is a global problem, and we have to act fast because of the COVID. People are not getting treatment and access to healthcare. So those two things we drive and looking for a solution, which will be global, it will be fast to develop, and it is cost effective. So with these three goals we searched, and that was a Cosmos DB was our choice because it gives all those threes and more than that. So we went with Cosmos DB because also Cosmos DB is not first time I'm using. We have used it in a lot of places, but with this noble cause, first time we're using Cosmos DB with the help of Dr. Kanungo. So our goal was to have continuous patient engagement, whether they are near or far, or local or global, and continuously monitor the care systems so that we can improve continuously. These are the two visions of our application. And because of Cosmos DB data, database with cloud native database, it gives all those things and made it happen. So in these are our features. We designed this to empower the patients, engage with them, and enhance our process. First, we network with our patients through our app, and we can give alerts, and we can chat with them with remote care. And based on their remote care, what we observe, we can give very personalized, curated information. We can push to their post to our users through our app. And then an engagement, we have 24/7 monitoring through our alert systems from your app. And we look into that, and we see how we can improve if they're close to us or not, if they're far away, which is the nearest healthcare, we can connect with them. And apart from this is a new thing, because we are not just only depending on the allopathic, we are also connecting to homeopathic and Ayurvedic, which in India is big, to see if combination of that can help diabetic patients. So this is one holistic approach we are having. And the data is coming. We analyze using Azure machine learning and cognitive services, and we get the insight, and we improve our process. So this is our whole model. And this is very high level architecture where our app is there. We have two apps, one for doctor, one is for our patient. And from lab, they can upload their tests to our storage. And our API will push to Azure like Event Hub. And then Cosmos DB will take that. And this is a big thing. With Cosmos DB is like a what do you call, work well with Azure Synapse Analytics. That was a big deal for us. And then we get all the hospital and pharmaceuticals details or research from them. So we get the data insight, and we use our analytics. And we also open to like other third-party data. We get like different, suppose weather or some pandemic disease informations. Everything we come through this Azure data factory, and we get to our Azure Synapse, and we do the analytics. And then that we present to the Power Apps for the immediate presentation and Power BI. And our professional network can use office team to use that, and also family. This is a big deal, because in our healthcare, nobody cares about family, because in Indian context, families plays a big role. So they can also access to our analytics and the well-beings of the patient. So we did that. And apart from that, we have APIs where other people can also talk to us. We talk to third party, and third party also can talk to us. It is like in collaborations, and we design this one so that way we can grow, together. That is the main thing. Then it is already available. If anybody wants to coordinate or partner with us, or we want to work together with. So this is the, please let us know, nimai@rx1.net, and Dr. Alok Kanungo will help to make it successful. Thank you. Any questions we'll take, or hello?
Hey, Bikram. Hey, look,
Yeah.
thank you so much for the great content and to see the just the important work that you and your team are doing. So we've got a couple questions. I'll start
Thank
off
you.
with one.
Sure.
One is, looks like you use a lot of Azure services together to build this application. I see Synapse, Cosmos DB, various other services there.
Right.
What were some of the surprises or challenges that you may have encountered? What advice might you give to other people?
Yeah,
building
actually,
similar apps?
yeah, Azure, we have worked a lot in Azure, but Cosmos DB is like a pleasant surprise. It is very fast to develop. Our developers, so that's why within few months we could bring up a whole system and start working. Like testing and all those things we could do, which was not possible with SQL or any other database. And it is very fast. And developers love the API, SQL API, because already they know the SQL, and so they're from SQL to transition to SQL DB was Cosmos DB was very easy. So, and also global, because we wanted some application, some database to be globally distributed. Like Cosmos DB replication is just click. You are in from US, you can go to India, or so that is also we are looking, because our application is addressing the global disease. So we are making it ready in the backend to global ready also.
Yeah, and that's great to hear. I also have another question. I saw that on that chart that you had some Nimai API, and then it sends some event streams to Event Hub, and then that goes on to the Cosmos DB Mongo API. Did you have previous experience using like a NoSQL database, and how is that different from using Cosmos DB, or if you were just using SQL in the past?
I have used Cosmos DB in different our applications. We have other applications we have used Cosmos DB, but I never used in healthcare context, and especially for diabetics in COVID time. So this is first time we did on healthcare, and we did because of the help of Dr. Kanungo.
Awesome.
Yeah,
And
go ahead.
Deborah.
I was just going to ask for the application, did you have any interesting feedback, or what's been the impact so far of having your app out there?
Yeah, we are getting good feedback, and people who have used, like we are in like a test users are there. Anybody interested, they can send nimai@rx1.net, NIMAI, Nimai, at rx1.net. We'll send, and we have almost 300 test users now we are doing, because like it is a healthcare applications we cannot open without proper testing. So once it will be ready, then we'll open to everybody. Anybody can just log in and get it from the marketplace, or like Play, what do you call, Android Play Market or something like that. Yep.
Yeah, and just one final question from me. Did you have any particular like key learnings? I know you said the development time was pretty quickly pretty quick with Cosmos DB, but did you have any like interesting challenges or things that you'd like to share with the with people on how your experience was overall?
Yeah, Cosmos DB is good that like you can design schemaless, and you can grow as your application grows. and also because in healthcare, our data sources from many places and many labs, hospitals. So we cannot stick to schema, bring the data, then we can integrate, So bringing the data is which is helping customers to be making our life easy. And apart from that, actually we had problem because first we started with Xamarin, but Xamarin, I think it is not that, we run into different situations, so that we change to Flutter, and that gives the speed. Customers to be backend and front end is a Flutter. It gives really speed to our development. So
That's cool. Great to see that. And then we also just had one more question
Sure.
in. Is this a multi-language application?
Yeah, that's a good question. Yeah, we are planning to. We have not done that because we did so fast. We are looking. Yeah, we'll implement multi because it is a global. So English now it is only in English, but in India also we are having a problem because in India we talk 26 languages. So we are addressing that problem. But once this testing is done, then we'll go to version 2. We'll have a multi-language. But now it is only English.
Cool. On the off chance, if they meant language by like software engineering language,
Yeah.
do you want to share a little bit about like the either tech stack or languages used there?
Which one?
Oh, on the off chance, so there's like the language of the app itself, but then
Okay.
if they're interested in like .NET, Java, Python, C#.
Backend, it is all API based. We use a lot of Azure functions and Azure Web API. Basically, we're Azure site. Actually, we do everything on Azure backend. That all done in the .NET, C#. But front end, we are using a grid, like a Flutter. It's called Gridle or something. Like I'm not well. It is like it is a Flutter. It creates that, and then it generates the. We can generate for iOS and Android. Then we publish those tools. But backend is all .NET.
Good to hear. This is awesome to see. We actually have a lot of questions coming in. So great engagement to see from the audience. As a friendly reminder to our audience, you can paste questions in the chat anytime. They'll show up to our team and we'll either answer them on the chat or bring them up to our speakers as well.
Sure.
So I've got a couple more questions here. One is about, I guess, could be a little bit related. One is about wanting to learn more about how you actually load all the data from their disparate sources. And then a corresponding question around, just to get a sense of the scale, how many RUs have you provisioned in Cosmos DB for this app?
Yeah, as I said, we are around 300 test users we have now. Customers, but Cosmos DB can handle as much as, because we are partitioning by user. So we have, like our base will be in millions, so that way we are keeping that in our design. And what is the other question you had?
So two questions. One is wanting to understand more about how you
load the data.
handle the data loads.
Yeah, okay. Yeah, there is a two type of data. One is online data, which we get it from app or API. And also this app API will open up, so anybody they don't have to use our Flutter app, mobile app. They can use web. They can call our APIs and they can develop their API. We'll open those APIs also. So that is like a online like a real online app data. But backend data, like there's labs, test labs, hospitals, or data from different research universities, because we will collaborate with different universities now. IIT Kharagpur here in Suffolk University in US. We are because the more people come, we want to make it really a global initiative. So that's why we will get data through the Azure Data Factory. So that we can schedule, and we have got APIs also. If they want to come through APIs, we have APIs they can call. So we want to integrate with as much as people, so that our data will be rich and our machine learning will be model will be really good, so that we can predict or we can help our patients much better.
Sounds like you have a lot of disparate sources. I imagine just having so many disparate sources, the schemaless nature must be quite helpful. You can just
Yeah,
change it
yeah,
on
it
the
is.
fly.
That helps a lot.
So do you, so I guess another question come in and around, just wanted to understand kind of the volume of the data loaded as well as just the general scale and RUs of the app.
Yeah, means volume of data, like that we can control through, like when we can bring like what is called cold data. You can say cold data, but hot data that is coming through API, and we are using what is called or functions where we can increase anytime. That is, and we are also using Azure Web API. Like there's app service, app services, and that also you can scale out. So now we don't have need for that because we are only 300. But when it comes, we can scale out. So we don't see architecturally any problem there. Or if anybody has any suggestions, we are open to that, because like we want to work together. So if anybody sees any problem or they want to have suggestions, or we are open to, we can talk, technically or architecturally, we're open to talk.
That's awesome to hear.
Yeah, it sounds like everything seems super flexible at where you're starting from in the beginning, and then you're planning just to scale up as you get more customers and more usage on your application.
Right.
Cool.
So I guess on that note, Vikram and Alok, is there anything else you'd like to say? Otherwise, we can wrap up the session and conclude on to the next speakers. Any last
Okay,
words?
So thank you. I'll just put that nimai@rx1.net to everybody. If anybody wants technically or want to use the app or any suggestion or advice, we are open to that, because we are just starting. So yeah, there's a long way to go. It's not the end, it's just starting. So all your help appreciated. Thank you all.
All right.
Thanks so much.
Thank you so much for coming. It was great having you.
Thank you.
All right. So Deborah, we have our next speaker coming up. We have Alan Smith, and he's going to talk to us about the power of using Gremlin or Graph API.
Excited to see it.
Hi, my name's Alan Smith. I work at Active Solution in Stockholm, Sweden. And in this session, called Graph of Thrones, I'm going to be exploring the graph database capabilities of Cosmos DB using the Game of Thrones as an example. A bit about myself. I describe myself as a developer, trainer, mentor and evangelist. I'm also an Azure MVP, and I do a lot of work with the community. I have a YouTube channel at Cloudcasts. I also speak at conferences and organise conferences. So I've been involved in organising the Cloudburst and the AI Burst conferences, which are free community conferences which we're hosting in Stockholm, Sweden. So a bit about Cosmos DB. I've been working with Cosmos DB for a number of years, using it in a few customer projects and also experimenting with Cosmos DB myself. As you know from looking at the other sessions in this conference, Cosmos DB provides us with a global distribution. We've got a fantastic elastic scale out, so our databases can scale very dynamically based on the load we place on them. We've got guarantees on low latency, and we've also got these 5 well-defined consistency models and comprehensive service level agreements covering the availability and the latency of Cosmos DB. So this is a diagram showing the 4 database models that we've got: the key value, column family, documents and graph, and also the various APIs that we can use to connect to Cosmos DB. And in this demo, I'm going to be exploring the graph database model, and I'm going to be exploring using the Gremlin API. And these two work together. If we're using the graph model, we'll be using the Gremlin API to be able to access that. So a bit about the architecture. If you've worked with Cosmos DB using the document model, you may be creating databases, and then within those databases you generate collections, and you can create your documents within those collections. If we create a Cosmos DB account using the graph model, what we're going to be doing is having databases, and within those databases we're going to be creating graphs. And you can generate multiple databases in a Cosmos DB account, and also multiple graphs within a database. So what's this gremlin creature doing? A lot of if you're looking at the different icons that we've got for the various Azure services, they tend to be very functional. We can see that we've got Azure Functions, we've got Cosmos DB, we've got various SQL databases for that. So the icons tend to be a pictorial representation of what the service does. In the open source community, for some reason they seem to want to use animals and creatures to be able to represent the various technologies. You may recognize quite a few of them there. And Gremlin, the guy on the bottom right, is the character that they've chosen for the Gremlin API. It's actually an open source API that's specifically for focusing on working with graph databases and the graph database model. So onto the scenario that I'm going to be demonstrating. I was watching Game of Thrones when it was on. I was kind of addicted to watching this all through the I think there was 8 series of it. And round about the end of Series 7, this competition launched in the Neo4j community. Now, Neo4j is a different graph model to the Gremlin API, and it offers different capabilities. But there's also a lot of similarities in these two models. And in this community competition, there's basically a contest where you could win prizes. And the idea was to be able to model the Game of Thrones world in a graph database using the Neo4j. And the screenshots are showing some of the graph representations of the Game of Thrones world. Showing how we can get some insight into how the various characters are connected, and also how characters are connected with various, relationships like marriages, parental relationships, siblings, and also being connected through various houses and religions and cultures and so on. It's a very rich, complex world that we've got in the Game of Thrones. So what I was thinking of doing was actually implementing this using Cosmos DB and also using the Gremlin API. I'd seen many people who've been doing this using Neo4j. So what I decided to do was to do this using Cosmos DB. I hadn't seen anybody else doing that. So I don't know if I was the first person to do that, but it was certainly fun to explore that. So traditionally, working with databases, you may be familiar with relational databases. Things like SQL Server and Oracle provide these various tables and schema definitions and relationships. And you spend a lot of time, building the tables, designing the tables, thinking about, the fourth normal form and all of this stuff, and designing all of the relationships within those databases. With Cosmos DB, we think about non-relational databases, both in the document and the column family, and also in graph. We're not really focusing on these kind of rigid schema with the relationships between the various entities in the databases. So the idea of using a relational database is when we're going to be querying that database, we end up doing lots of joins if we're interested in selecting things. And we're basically leveraging these relationships in the database. So here I'm using the AdventureWorks sample database in SQL Server. And I'm getting the sales per region, the sales categories per region. So what I've got to do is I've got to select from the country region table, and select from the addresses table, and then join onto the sales order, join onto the sales order detail, and then also join onto the product and the product category. And as we start doing these joins, the queries do tend to be a bit inefficient, and so you do tend to hit scalability problems when you're working with a relational database model. That's showing the execution graph for that type of query that we can run on that model. So if we're thinking about taking the Game of Thrones world, and we've only got relational databases as our data model, then we're going to think about, well, let's generate a table for all of the people. We'll generate a table for all of the houses. And then we can start to model and basically place in these various characters. So Tyrion Lannister basically serves House Lannister. Varys also serves House Lannister. And we can basically build this model by using a many-to-many relationship and creating a table to basically represent those relations. However, Varys also serves Tyrion Lannister. This has just broken our relationship model because we don't have the structure within our database schema to be able to model that relationship. However, if we're using a graph database, we're going to be defining the entities like the houses and the characters as vertices within, or vertices within the graph database. And then the relationships are going to be defined using edges. So there, Tyrion Lannister can serve House Lannister, Varys can serve House Lannister, but there's nothing to prevent Varys from serving Tyrion. We can just generate that relationship or that edge and link those two entities together. So this gives us a very, very flexible model that's going to be very useful for being able to work with more complex relationships. I think a good example of the graph database is something like LinkedIn. You know, you've got a LinkedIn profile and, you know, you work for a certain company, you've got various co-workers, you went to a certain university, you live in a certain town, and you've got connections with certain co-workers, and you're a member of certain groups. And all of these relationships can be very easily modeled using a graph database, and also, more importantly, very efficiently modeled. So in comes Gremlin, the graph traversal language that we're going to be using in this demo for actually modeling this. So when we're actually doing what we would call a query on a graph database, we don't call them queries, we actually call them traversals. And Gremlin is a graph traversal language that allows us to be able to run these traversals on the graphs and be able to extract information from that. So we have a sequence of steps, and they can be potentially nested. And each step is going to perform an atomic operation on the data stream. So we can do things like mapping, filtering, and then various side effect things like sorting and counting and stuff. And we'll see all of these as I run through the example queries in the database. Now, I really don't like the term NoSQL because NoSQL is really describing that a system does not support the SQL programming language. I prefer using non-relational. So think about the document database in Cosmos DB. It's a non-relational database, but we do use SQL to be able to query that. However, I do think NoSQL is appropriate when we're using the Gremlin API. Because if we're doing using a relational model, we're going to be building up a query like this to be able to select from you know, the various relationships if we're interested in loyalties on various people. Whereas in Gremlin, we do something like this. We do g.v Tyrion.out serves. And what I'm looking for is basically anybody who is serving Tyrion. And I'm basically able to build up that relationship in a very, very simple and very efficient query. So, first step was to gather the data for the Game of Thrones. It is incredibly complex. There's a lot of stuff going on in the TV series. So what I did was I used the Game of Thrones wiki site, and here we can see the information on the character of Jon Snow. We get all of this information provided in the wiki for all of the characters within Game of Thrones. So what I did was I used a technique called screen scraping to be able to take this information and to be able to get the information into a machine digestible format. And I chose JSON to represent the information. So the screen scraper will basically go in and it would extract the name, the father and the mother of the character, the siblings, the religion, and so on. And you can see it's basically extracted out the various data like the titles and allegiances and so on. And what we can then use this JSON to actually drive the data input. So it's kind of a two-stage process. The first stage is to extract all the information from the wiki and get it into one really, really big JSON file. And then we're going to pass that JSON file and run the queries to be able to get the information into Cosmos DB. So this is what the query language will look like when I'm using the Gremlin API to get the information into Cosmos DB. I'm adding a vertex, which is a character, which is Jon Snow. I'm then adding the relations to Jon Snow. So what I'm doing is basically selecting that Rhaegar Targaryen is father of Jon Snow. Lyanna Stark is mother of Jon Snow. This is from Series 7, by the way, so I think that's what we knew in Series 7. No spoilers, but I think that data did change a bit in Series 8. We can also drop on the allegiances. Jon Snow serves House Stark and House Targaryen and the Night's Watch. Jon Snow is from the Northman, and Jon Snow worships the old gods of the forest. So we can basically add on all of these various relationships and characters to be able to build up the whole graph of the Game of Thrones world. And this is kind of showing you know, the different allegiances and connections that we will have on Jon Snow. So building up the actual Graph of Thrones model, I'm going to jump out into the Azure portal now. And I do have a pre-prepared database, but I'm going to create a new one anyway, just to show you how this process works. So I have my Cosmos DB account, and this has been created using the Gremlin API. And if I go into the Data Explorer, I've basically created a DB of Thrones test, which I have populated with a test data. But I'm going to generate another database just to show you how that process works. So I drop on a new graph. I'm going to create a new database called DB of Thrones. I'm going to select a new graph, which is called Graph of Thrones. And for the partition key, I'm going to use key. Which is going to be coming from the actual data. I'm going to leave the auto scaling on with a max of 4,000 RUs. The reason I do this is the data input process is fairly heavy. We're going to be running at lots of transactions. So I want the Cosmos DB database to actually scale out, scale up, and be able to actually meet any capacity that I want to throw at it. So that should be fine for that, and I should be able to create that graph. And whilst that's churning away, I'm going to jump into Visual Studio. I'm going to need to, I think I've got these settings set. I think I've spelt this correctly, DB of Thrones and Graph of Thrones. And I can just show you the code that's going to pass the data. So, Game of Thrones edited.json. This basically has some cleanup work. When I got the raw data out, which is this Game of Thrones.json, there were some things I needed to actually change and modify. So there's usually a bit of a cleanup when you've got to do a data import here. But here we can see the actual JSON file for all of the characters. And if I scroll down to the bottom, you can see there's about 9,500 lines of data here, listing all of the characters that I could extract out of the actual wiki site, and all of the relationships and so on. And what the console application is going to do is to basically pass through that JSON file and build up the actual queries that we're going to insert into the Cosmos DB database. So I'm just going to drop back to the portal, and you can see hopefully that this has been created. We've got DB of Thrones, and within Graph of Thrones, we've got an empty graph. If I execute this query, you can see that no results are coming back from that query. The graph is empty. So hopefully I should be able to run my console application and get that data import running into the database. So I'm just going to run the console app. And here we can see that we're pushing in all of the character data, and there's going to be quite a lot of characters. We'll see some information statistics later on sort of how large the actual database is, but there goes all of the actual character information. A couple of exceptions there. I'm not sure why those were occurring. I maybe need to go in and troubleshoot those. Now we're pushing in the allegiances, we're pushing in the cultures, the religions, and now we're dropping in all of the actual relations. And there's going to be a lot of these edges that we're going to be adding, linking the various characters to the other characters within the Game of Thrones world. Okay, so whilst that's churning away, I'm just going to drop back to the portal, and I should be able to start running a few basic queries on the actual Game of Thrones. If I actually run g.v now, we should see that we've got some information here. I'm just going to minimize these windows here, so we've got a bit more space to actually view the actual graph here. What we can see when we're querying this is we're getting the main character of Eddard Stark, and we're also getting the relationships to other characters, and we're able to explore this model and bring out the other relationships from these. I might just zoom out of the portal a bit, see if I can get this in something that's a bit easier to digest. So as we're basically navigating this, we have this model now that we can actually use to explore the Game of Thrones world. The input is now complete. You can see there that all of the actual data has been pushed in there. So we can now start to explore this graph model. So querying this is bringing back all of the characters. I can select any character within the Game of Thrones world. That character is going to be displayed, and then we can go on to House Mormont. We can expand House Mormont, and we can see the different characters that also serve House Mormont, along with John Mormont, who I've selected. If I expand the properties again, we can see all of the people who are basically serving that particular house. Now, typically, when you're building an application, you're not going to be using this graphical view to explore the Game of Thrones world. So what we're going to be doing is looking at the actual queries that we're going to be running in this window here. So, I'm going to look at some of the actual data. G.V is going to select all of the vertices within the graph. I can also do a G.V.count, which is going to tell me how many vertices we've got. So there's 872 vertices. And then if we want to look at the edges, we can do G.E count. And we can see that there's 2,095 connections between each. What I can also do is on the vertices, if I go to G.V, I can look at the label and then do a group count on the label and run that query. And what this is doing is telling us that we've got 660 characters, 164 allegiances, 38 cultures and 10 religions. If we look at the edges and do a group count on them, we can see the numbers of the different edges. So there is 119 marriages in there. We've got 193 is father of, 925 serfs. So you can basically see all of these differences that we've got, all the ways that these characters are connected. What we can also do is do queries to select what are the relationships between these various characters. So if I go to G.V, I'm actually going to paste this in. If I just query for Eddard Stark, this is basically bringing up the JSON which is coming back, which is describing Eddard Stark. So that's querying that particular vertex, the vertex with that particular name. And if I want to find out who his children are, I can look at the outbound relationship from Eddard Stark, and I can ask for is father of. So what this is bringing back is Eddard Stark's children. And you can see we've got Sansa, Arya, Robb, Bran, Rickon, and Brandon coming back here. If I change this relationship from an out relationship to an in relationship, then I'm going to be looking for Eddard Stark's father, which is coming back as Rickard Stark. So I can now take Rickard Stark, drop Rickard Stark in there, change this back to an out, and then we've got Rickard Stark's children. And you can also combine these queries together. So if I want Rickard Stark's grandchildren, I can just copy paste that query there. And what now is looking for Rickard Stark out is father of, and then for all of those nodes, we're looking for out is father of as well. So you can come back here and you can see the list of grandchildren from Rickard Stark. So it allows us to be able to explore all of these various relationships within the Game of Thrones world. So if I'm going to go back to Eddard Stark, and what I'm going to do is to look at who Eddard Stark serves. So I'm going to basically go out and then go serves, run that query there. And you can see that Eddard Stark serves House Stark and House Baratheon of King's Landing. Now what we can do, because this query is returning House Stark and House Baratheon of King's Landing, what I can do is basically drop on. I keep calling these queries, they're actually traversals. This traversal is bringing back those two results. If I now go in and drop this onto the end of the traversal, this is going to return, this bit is going to return these two entities. And then what I'm looking at is, well, who also serves these two entities? So from these two entities, who has an inbound relationship to serving those entities? So if I run that query, this is showing us everybody who serves alongside Eddard Stark. So is connected to Eddard Stark through, the two entities. They basically serve the same entities there. So what we're doing now is kind of exploring the relationships within Game of Thrones to find out, do these characters have quite a lot in common with them? Do they serve alongside each other? There's some more complex things. What I'm going to do here is just drop in this traversal here. And this one is going to look for the most influential organizations. So I'm looking for G.V. I'm selecting any all of the vertices, and they have an outbound relationship which is serves, and then I'm doing a group count and ordering by the value descending. So what this is going to show us is, which institutions within the Game of Thrones world have the most people serving them. So House Stark comes up at the top with 86, and then we've got House Targaryen with 84. And if we scroll down, we'll see, the lesser houses within the Game of Thrones world, and you get right down to the bottom, and there's some of them where there's only one character that's actually House Humble only has one character that has an allegiance to House Humble. So Humble by name and by nature. Okay, so my kind of idea by this, the way that these graph databases are used within things like LinkedIn, is to be able to do things like friend recommendations. So I thought it might be fun to see if we can do a friend recommendation within the Game of Thrones. So I'll round off my demo just by dropping in this traversal there. And what I'm doing is taking Jon Arryn. I'm looking at both the inbound and the outbound relationships, but I'm limiting the results to only characters. Only characters are going to be present in friend recommendations. And then I'm doing the sorting to basically sort all of the characters in the Game of Thrones world that have the most in common with Jon Arryn. Jon Arryn comes out top. He has the most connections with himself, but then we've got Peter Baelish coming out with 10 shared connections, Robin Arryn and Lisa Arryn here. So this is kind of like a friend's recommendation from Game of Thrones. Peter Baelish is coming out top. I would be scared if anything was recommending Peter Baelish as the best friend. But let's drop him in anyway and see what comes out. And it's saying Jon Arryn is got 10 connections. Those are 10 shared connections. And we can go down and find these other characters. We can take Cersei Lannister if I can find her, and we can drop her in and see what her friend recommendations will be. And then we've got Jaime Lannister coming out as the top friend recommendation there. So that was quite accurate if you watch the Game of Thrones series. So takeaways on this. If you've been working with traditional models, such as regular relational databases, or maybe working with the document model in Cosmos DB, the graph model is very different. I try to think to that adage, if your only tool is a hammer, then every problem is a nail. We do now have these graph capabilities available in Cosmos DB. And if the challenge that you're trying to solve seems to be very graph related, it could be suited to working with this graph model. Definitely worth exploring and working with this. This is the first thing that I built on the Gremlin API in Cosmos DB. It was a bit of a challenge for me to get my head around how the graph databases worked, but it wasn't too difficult to get the actual model working. Most of the challenges were related to the data import. And we are using the graph model at my company in a couple of customer solutions. So I definitely recommend spin up an instance of Cosmos DB, run through some tutorials and experiment with the graph model and see how it works for you. So thanks for listening to my session. My name is Alan Smith. I work for Active Solution, and I do have some content up on YouTube if you want to go and check that out. Enjoy the rest of the conference.
That was so cool.
That was amazing. I really love the topic, Game of Thrones. I don't watch Game of Thrones, but if I did, I would be even more in love with this. What did you think, Deborah?
Yeah, thanks so much, Alan. That session was really great.
Yeah.
I love seeing the way it just kind of took something we can relate to the data import with autoscale. Always love it when autoscale can help with the data import, even if the other workload doesn't require as many RUs. It's just cool to see all the relationships broken down like that, especially when you consider like what kind of SQL query you'd have to write to generate the same thing. It's probably like this long versus like a 5-part graph query to express something that's so easy for us to say and understand, but way harder for like a piece of technology. What about you? What was your favorite part?
Yeah, I really, really like seeing that comparison because it really made it seem like it's so much easier to use the Gremlin API to do these graph relationships. I also like seeing the portal being used actively to look at all of the relationships and all the nodes and edges. And I thought that was really cool. You can just click and then see all of those details. Really, really great presentation, I would say.
Yeah, definitely. I love seeing the graph expander charts. It's actually running the queries live as they're going along, so you can quickly kind of interactively explore your data.
Yeah, that's cool. And then the last part, he talked about some recommendations for friendships. That query was also really cool, interesting. I wonder if we can add in additional parameters as an evil or good person on the parameters to kind of filter better friends on there.
Yeah, I guess the awesome thing about Graph API is like there's relationships in terms of, like, he made the use case of LinkedIn and graph sharing, but there's just so many other use cases too, where basically any kind of data where you have a relationship. For example, we have customers who do supply chain management. Like if component A has some delay or has some housing effect that's BCDE down the line, there's obviously social networking, friend recommendation, component as well, but there's just so many applications of things you can do with Gremlin API and Cosmos DB.
Yeah, and it's so easy to get started creating your own applications, your own queries and relationships. And I really like the data import that he used with the screen scraper and all of that. It seemed to be quite easy to get up and running. I'm sure for other bigger real world applications, it's also pretty simple.
Definitely. And I think the nice thing about Cosmos DB Gremlin API is for if you have a workload that has very high transactional volume, where you're actually frequently running these kinds of queries, or you're doing a lot of updates, right? If the graph is constantly changing, people are leaving, or not necessarily people, but items or entities are leaving, exiting, relations are changing. Cosmos DB makes it super easy to start small, like Alan did in the video, 400 to 4,000 RUs as the autoscale entry point. By the way, as an aside, we actually just, I think like 4 days ago, announced an update where autoscale can now go between 100 and 1,000 RUs. So for free tier customers, you can use autoscale completely for free. Of course, if you need more RUs, you can go way up. But even with that, just being able to start small and then later scale up and add more RUs and as your data and your request volume changes.
Yeah, it was really great to see that. I admittedly haven't been using the Gremlin API so far, but having seen it in action, I really see the power of using it for these type of relationships and applications.
Definitely.
Yeah.
So speaking of things related to scale, performance, one of the things in Cosmos DB that's really important to get right, and I think Alan got right in his video, is partitioning. Cosmos DB distributes your data horizontally across many servers or partitions to enable you to elastically scale as your workload grows up or even as your workload shrinks. So the way to get the best cost and performance in Cosmos DB is to make sure you have a really great partitioning strategy. To that end, our team has put together a very short but very content-packed video to explain how to choose the best partitioning strategy for your Cosmos DB workloads. Let's play the video.
Achieve incredible speeds at any scale and keep your costs low with a well-planned partitioning strategy on Azure Cosmos DB. Partitioning involves writing data to servers in a way that optimizes both reads and writes. It's important for all applications, but becomes critical the more you scale as data spreads to more servers. Azure Cosmos DB stores data in virtual buckets called logical partitions. It relies on a partition key to determine which of these buckets to put new data in and where to look for data during a query. When choosing a key, start by testing your most important requests against the following 3 guidelines. 1. Find the write balance. Test your partition key to see how it distributes writes. The goal is to avoid hotspots and rate limits by achieving even distribution of storage and throughput across logical partitions. 2. Aim for a single partition query. Look to see how many partitions get hit when you run your most frequent queries. Ideally, you want to avoid the cost and latency of involving multiple partitions by choosing a key that queries a single partition. 3. Understand cross-partition query trade-offs. If you do run cross-partition queries for less important workloads every once in a while, it won't impact your overall experience. But if it's more than that, you can use an array of discrete values for the partition keys in your query to target a subset of partitions. Looking to unlock the scale and performance of Azure Cosmos DB? Remember, it's all about the partition key.
I love that video. So much content, so little time.
Yeah, action-packed content. Yeah, also, I would like to basically encourage everyone in the chat. We do have a hashtag Azure Cosmos DB Conf for you guys to participate, ask any questions, and share on your social media. We'd love to see you guys actively on there. All right, Deborah, we have our next speaker coming up. We have Robert Mao, and he's going to be talking about migration to Azure Blob Storage and Cosmos DB from Couchbase/Elasticsearch.
Hey everyone, 1 second. Can people see my slides? There we go. Okay. Awesome. So, hi everyone. My name is Robert Mao. I'm a software engineer on the monitoring infrastructure team here on LinkedIn. And today I'll be talking about NoSQL Cloud Adventures, our journey in moving our product from Couchbase and Elasticsearch to Azure Blob Storage and Cosmos DB. It's an honor and a pleasure to be with you here all today. So, to go through this, what we're going to talk about, first, we're going to talk about what our product exactly is, in this case, Inmon, the background on the Couchbase and Elasticsearch setup that we had for it, how we set up Cosmos DB and Blob Storage to replace these two things, and finally, the juicy bits of the topic, what are the takeaways that we feel were most important from this entire journey. So, starting off with Inmon. Well, what is Inmon? In a nutshell, the purpose of Inmon is to generate synthetic requests and to visualize test results for real-time availability monitoring. This is an internal tool that we developed over here. Language-wise, it's written primarily in Python for the backend, a bit of Golang, and primarily with vanilla jQuery for the UI and other bits. In terms of what it's equivalent to on the open market, it's roughly about there with Catchpoint and Uptime Robot, if you're familiar with those tools. Tools essentially for synthetic monitoring and getting a live view of how your test runs. And here at LinkedIn, it's used by dozens of teams here for internal tooling and external endpoints that you might be familiar with, such as sales, recruiting, payments, all kinds of different bits and functionality of the entire site. And if you look at the two screenshots that I have over here, I mean, what generating synthetic requests means in practice is you take a URL and then you poke it over and over. And if anything goes wrong with this URL, well, then you'll see that immediately with a test result, and then you could dive in and troubleshoot. If you look at the top page, the top screenshot I put over there, you can customize a list of tests, a list of endpoints you put on a home page. Back before COVID, when we were still in the office, it was not an uncommon sight to see teams set up a custom list of about a dozen or so tests, as you can see over there, put that on the TV screen, and just have it there, like in a workspace area. If those green boxes start turning red, or if they start disappearing entirely, then you know that something is up with Inmon, with the site, or with your product, and you should probably take a look at that immediately. Likewise, you could dive down into the plot page below and take a look at the health of your service over time in the immediate last 5 minutes, hour or so, and just get like a brief overview into how your service is doing with the synthetic pokes from Inmon. As far as what kind of tests we support, again, we poke a URL over and over, and there are two primary ways to do this. You can curl an endpoint and get back the result, or you can run a full-blown Selenium test on the endpoint, loading up in a browser, running JavaScript, all that kind of stuff. And as far as how you determine whether the result was successful or not, there are a bunch of ways you can validate it. Some of the most common ways we do are status codes, 200s, 4xx's, and everything, running searches and checks over the response body content, all that sort of thing. And you can see an example of a test result to the right. So, one other thing that we do on top of running these test results is we save what are called call trees. In the open world, these are better known as distributed tracing. The idea is that when you run, when you hit a given URL, it's going to touch a lot of stuff behind the scenes. We manage this via Kafka here on LinkedIn, and we generate all these service call events when you hit a URL. So when you hit a URL and it fans out and touches other stuff downstream, all this will be saved via Kafka, and Inmon will collect these results and return them back to you via the UI. These call trees can be quite small, as you can see on top, quite bigger, medium size, as you can see at the bottom, and really big, too big to fit on one or even two slides over here. And the idea behind these service call trees, these distributed tracing events, is if a given test runs, fails, you could then drill down to what service may have responded with a bad error code, what service may have taken a long time, and then easier troubleshoot what may be wrong with your test and service that you're testing. Now, architecture-wise, to give a brief overview of how Iman works, we have Iman Web, which is the UI portion whose screenshots I showed earlier. That's what the end user will primarily interact with to view results, create their tests. Iman Web will talk to our configuration data store, previously Couchbase and Elasticsearch, now Cosmos DB and Blob Storage. The configuration data store in turn talks to Iman Scheduler, which fetches configs on intervals and sends them off to Iman Tester, which does the job of curling or running a Selenium test on the URL in question. Iman Tester will then send off its metrics for monitoring and visualization of these test results over time, and Iman Tester in turn will send its results over to our result data store. We have a separate app, Iman Extractor, that will talk to Kafka and scrape all these service call events from the various Kafka topics, and then shove them back into the result data store, where then Iman Web retrieves both results and call trees for you to go ahead and view at your leisure. So to give you an idea of what kind of scale we run at, we have approximately 40 million test result objects with associated static object blobs, things like screenshots, response headers, response bodies, and such, sitting in Cosmos DB at this time. These 40 million results are the result of about 1,700 active tests, running at minimum once per minute, but more often once every 15, 20, 30 seconds. Again, this is Iman is meant for live monitoring of your service. And as far as call tree objects, we have about 120 million of them currently stored within Cosmos DB. This 120 million objects was in Cosmos DB post-migration came from 1.5 billion call tree documents in Couchbase prior to the migration. So we definitely were able to see significant storage improvements when we made our migration from Couchbase and Elasticsearch over to Cosmos DB. So with that in mind, let's talk about how exactly we ran Couchbase and Elasticsearch. So there are 4 primary objects that we store within our data store. The first is going to be static objects. These are things like screenshots, test response headers, and so forth, binary blobs, that kind of thing. We have call trees, again, the distributed tracing, where for a given call tree associated with a test result, there might be anywhere from 10 to 100 or even more than 100 individual service call events, all stored as JSON objects. There is a test result object itself, which is a JSON object containing the test result run info, status code, what host service did, that kind of thing. And lastly, we had the test configs, which are the JSON definition of the test itself. What URL you're hitting, what status codes you're looking for, the validation criteria, that sort of thing. So with that in mind, what were the challenges we faced with Couchbase and Elasticsearch? Well, to start with, why did we pick Elasticsearch to run in tandem with Couchbase? This was because of problems that we saw with Couchbase's index slowness. At the time, Nickel, its query language, wasn't quite stable enough for us, so we elected to run Elasticsearch on top of Couchbase to query through and grab our data on the fly. Now, the problems that we saw with Couchbase were that it ran out of memory very frequently, and we got pinged on on-call for this a lot as our tests grew and as we ran out of memory. We suspect that the internal retention for Couchbase objects stopped working due to bugs with it, and the end result for this was that screenshots and logs were dropped from our saved test results. And this presented a real problem because users would come to us occasionally asking, hey, my test failed for whatever reason, but I can't look at the screenshots and I can't look at our response headers and bodies to see what exactly went wrong. So this led to blind spots in our monitoring. To try and get around this, we bumped the memory quota on the separate bucket that we use for static objects as a stopgap, but this will only work for a couple of days or weeks before it fell over again, and we had to go back and do this over again. On top of that, our call tree bucket cross-data site replication would get wedged, leading to even more out of memories. And ultimately, this caused us to pause across the data center replication entirely from a region, leading to a single region being our only data store fabric for this app and putting us in a rather vulnerable position. So with that in mind, we needed to go and find another solution. So why though blob storage and Cosmos DB in particular? Well, to this end, we explored a number of different options. The first of which was Espresso, which is an internal document store that we use here on LinkedIn. We considered it, but Espresso was expressly designed for balanced reads and writes, and our traffic is much more write heavy than read heavy. The vast majority of the test results that we shoved in are successes, which people are not typically interested in. They're more interested in failures, which constitute perhaps 1-2%, if everything's going right, of the overall test result set. So that was also not a win. Plus, InMod monitors Espresso, and using something that we monitor directly within the tooling that we need to make it work didn't seem like a particularly wise idea. Here on LinkedIn, we also run CAS, Couchbase as a Service, which another team manages, but they explicitly said that this service is meant to be used as a cache to speed things up, not as a source of truth, which was not accepted for our use case. We needed a solid, bulletproof data store for what we were doing. We also thought about just obtaining additional Couchbase and Elasticsearch nodes, but this wouldn't really have addressed the internal retention problems that we were facing. It would have cost us quite a bit of money, and this would have been undone with Blueshift, our ongoing internal migration of LinkedIn apps over to Microsoft Azure. Lastly, we looked at Kusto and Inlogs, which is another solution here on LinkedIn for storing logs, various objects, but this would have required a major refactor from our consumers and how they query data from InMod's API. So that was also a no-go. So after exploring all that, we hit upon blob storage and Cosmos DB, which checked off all the 3 boxes that we were looking for. It's available. Microsoft's very good about keeping these things up. It's scalable as much as your wallet will allow for however much data you're shoving in there, and it's stable. Microsoft, again, has a vested interest in keeping these things up and running as much as possible. So moving on to static objects and design considerations therein. Frankly speaking, using Couchbase for the binary blobs that we were storing within it was not really a good idea. Couchbase was not really meant for storing things like images or stuff like that. But it was a perfect fit for Azure Blob Storage, a key value store. One thing that we did have to keep in mind was the number of write operations. Because blob storage bills you by the number of individual writes, it made sense to go and we write way more than we read. What we did was, for our key, we took the test result ID, and for our value, we took we now stored a gzip archive containing all 5 or so static objects, screenshot, response header, response body, and so forth into one. Previously, with Couchbase, we would store each of these things individually, but with blob storage, we chose to store all of them at once, merging 5 or so writes into one to save on cost for us. And when reading, like when you click on the button for screenshot, when you click on the button for response header, behind the scenes, the UI will then pull the entire gzip archive. It will then unzip on the fly and dump the individual object we're looking for. Again, because we write way more than we read, and the reads are limited largely by user traffic, which is users clicking through the UI, we felt that this trade-off was very much worth it for us to save on the cost of individual writes to blob storage. And architecture-wise, this required changes only to 2 of our apps, InMod Tester, which runs the tests and shoves them back in InMod Web, and InMod Web, which takes the tests that InMod Web, the objects that InMod Tester gives over, and shoves them now into blob storage rather than Couchbase. So moving on, you can get an idea of the kind of scale that we run at. As you can see, as mentioned earlier, we write way more than we read. As you can see, like something like, almost like, yeah, an order of magnitude, like more than, we write pretty much an order of magnitude more than we read. And you can see that the performance-wise, the vast majority of our queries and of reads and of writes and reads perform quite admirably, with most of them running in under 500 milliseconds, with very, very few, almost none. Yeah, none over here running over 5 seconds. So pretty bulletproof service in our experience. Yeah, and over here you could see again, way more writes than reads. So yeah, perfect. Again, in our use case, it made sense to go and bundle together those writes, and even if the reads ended up being a little more costly. But yeah, moving on now to call trees, what we call distributed tracing. This was the first use of Cosmos DB for IDMON, and it was a very successful one. As soon as we set this up, the constant on-call incidents at the rate of 3 or 4 a week that we got for Couchbase and Elasticsearch essentially went away, even though we were still using those for test results and test configs. We only had to change 2 of our apps, IDMON Extractor and another one called IDMON Retention for write. Extractor is the app that checks Kafka for the service called event nodes, and now sends them off to Cosmos DB rather than Couchbase. And Retentioner is something that we have for just going through and updating like the time to live per node for results that users may want to keep longer in our data store for further examination. We also changed IDMON Web for reads to hit Cosmos DB rather than Couchbase, and we made other changes for partial call tree node storage, indexing, and collecting as many call trees nodes in memory in one go for to minimize writes, in keeping with the theme of minimizing individual writes over to Azure services to save on cost. Here's an example of an individual call tree object that we store. As you can see, just an object, and it contains stuff like caller container, environment, hostname, and such, what particular hostname serviced it, what URL it's hitting, and then its fan out. Like when it hits something, what do its children hit, and what do their children hit, and so forth. So you can really make quite a massive tree from all this stuff. And again, getting into some of the numbers and metrics, as you can see, Cosmos DB is pretty much as bulletproof as blob storage over here. We're on the order of like 60, 70,000 writes per minute, and very, very few errors, just a few flukes now and then. And lastly, moving on to test results and configs. So for test results, again, we only have to make changes to IDMON Web. For IDMON Tester, we can retain the same path for result emission. What did make things a little bit more hairy for results, though, were queries and indexing. We learned particularly over here that partition key selection is very important. Cross-partition queries are pretty slow, and you really want to make sure as much as possible that when you query something, it sticks within one partition. So with that in mind, for test results, our partition key ended up being test name, since the vast majority of our queries are going to be for a given test or a given set of tests, and test configs. So this test configs weren't as important because we store way fewer of those than test results, but it made sense just for cleanliness to store config type, the actual live tests, the test revisions, and so forth. And on top of, to try and get around the problem of working around cross-partition query updates, we would only set up composite indexes on fields on which we actively search. So on top of the test names, we will also search on stuff like successes, failures, so we can go ahead and grab, okay, a list of tests that were successful, a list of tests that were not successful within the past half an hour or so. And again, moving on to metrics, the request latency that we saw for Cosmos DB in this regard was also pretty excellent overall. Again, vast majority of requests on the order of 500 milliseconds or less. So, takeaways from all this. So for static objects, test results, and call trees, our migration went pretty smooth. And the reason for this was because we store test result objects for a maximum of 30 days. And the idea behind anything after that, it just ages out, we delete it to avoid holding onto it forever and raising our storage costs. So for this reason, we were able to get away with a dual write and read strategy to make our transition from Couchbase to Azure very seamless. What we did was, once we got our Azure installation up and running, we started writing and reading to both Couchbase and Azure for 30 days. After those 30 days were up, we had the same set of data overall within both Couchbase and Azure. We then turned off reads to Couchbase, but kept writes on, just in case something went wrong, and we would have to fall back. After we were confident, about a week, 2 weeks or so, that Azure was serving everything, nobody was complaining that they couldn't find the results and such, we then turned off writes to Couchbase entirely and then decommissioned our Couchbase cluster, moving on to Azure entirely. Test configs, though, because those aren't aged out, unlike test results and stuff like that, we did have to go and manually migrate those from Couchbase to Cosmos DB. But because it was only a few thousand JSON objects, it was not a particularly difficult job to write a one-off script to download our test config objects and then shove them into Cosmos DB and to have them up and running. Now, if you're moving a substantially larger data set, if you don't have the luxury of just having stuff age out and being able to read and write, we did some looking around and found that Microsoft for Cosmos DB does offer inbuilt tools for stuff like MongoDB to go and migrate existing data over to Cosmos DB. So worth keeping in mind. Other stuff that came up were, so we use Python for this, for our app. And so the Python Cosmos DB client, there were some API changes mid-development that we had to deal with. Sometimes this helped. For example, we got official support for an external proxy that we use to go and talk to the Cosmos DB API rather than have to wire it in ourselves. But other times it caused issues. For example, we found that the retry logic in the API client didn't really work, and we had to improvise and implement this logic ourselves. There was some other stuff that we had to keep in mind, like translating some Couchbase functionality within Cosmos DB. Counters and atomic updates required using Cosmos DB's optimistic concurrency control via the ETAC headers to ensure that writes didn't get lost. And this functionality mapped over very neatly from Couchbase or to Cosmos DB. And again, to re-stress this point, partition keys, partition keys, partition keys. This part was very crucial that we found when we were setting this up, because when you pick a partition key, you can't change it. You're stuck with it for the data set, and so that first choice is very crucial. You got to emphasize, like, to avoid cross-partition queries whenever possible. It can be done, but if you're going through many partitions, some of these queries can be on the order of like 30 to 40 seconds. And if you're doing an offline processing or just tweaking around behind the scenes, this is a big a deal. But if you're trying to do things like pull test results by response code or something else, like across all different test names, where we don't explicitly index or partition on, then these things can be quite slow. We suspected that the Python Cosmos DB client didn't do parallel queries. Like if you were running a query that's, for example, spanned 100, 200 or so different partitions, we suspected, but we aren't quite sure, that it would go through them iteratively rather than in parallel, which is quite slow. However, we found that as of December 2021, last year, there is now an asynchronous client for Python for Cosmos DB where you can fan out and make these queries in parallel. So yeah, I hope you found all that useful. It was definitely quite a journey migrating from Couchbase and Elasticsearch over to Cosmos DB and Blob Storage. And I'm happy to take questions now. Thank you very much.
Hey, Robert, great, super amazing session. I really love to see all the great improvements that you guys made. I wrote down a couple notes, like I saw you had 120 million call tree objects in Cosmos DB versus the 1.5 billion in Couchbase, which is really notable on my end. I was just curious about your partitioning strategy, by the way. You mentioned the PK for the test results was this test name. What was the PK for the test configuration?
A test configuration, yes, I should have mentioned that, stressed that more. A test configuration was just a test configuration type. So for giving like a test, like we'll say like foo, bar, whatever, you will have like the live test right now. So that would be for test config, we'll just call that like test config. And then we'll also have revisions. So past like versions of the test config. And then if you're looking for revisions, you could just draw for that. So we partitioned on config type.
Oh, got it. Cool. This is really, really great to see.
Well, I think you distilled kind of the essence of partitioning super well. I wrote a note to ask, what was your partition key? And then you had a really great section on it. I think the advice you give is spot on, especially I imagine at the scale you're running into. If you have small app, cross-partition queries is typically fine, no problem. But once you get to, I think, the millions and billions of records that you're storing, I definitely want to get those single partition queries.
Absolutely.
I also wanted to call out one other thing that I thought the kind of journey you shared was really exemplified really well, which is that there's a limit to how much you can scale up by just adding more CPU, memory, and storage. And at some point, these kinds of traditional systems have a natural bottleneck. And to some extent, it sounds like you were actually just scaling up memory for quite a bit of time. You'd get on call, add more memory, on call, add more memory, until you finally decide to make a shift. Can you tell us a bit more about kind of how you and when you finally decided to switch over?
Yeah. So, like I mentioned during the talk, using using Couchbase and Elasticsearch for stuff like static for static objects was frankly kind of an ill fit from the very start. So we were running into problems for that, but it was like a stopgap solution that we made. It predated my time here at the company, but it came to the point where just after a few months, where we started just getting constant pings like for the alerts that we set up, like on the order of like 3 or 4 a week, then we really just started putting our foot down and saying, all right, this isn't going to work. It was when these incidents started rolling in that we figured that this isn't going to work. We should start looking at something else. And that's when we went through the internal process here to go and like request Azure Cosmos DB, blob storage subscriptions, and start actively looking into that to decom Couchbase and Elasticsearch entirely and move over to that.
Cool. I also had another follow-up. So you have like a very high write-heavy workload. I think you said something like 50 or 70,000 writes per second, something like that. And during that migration process, you mentioned something about having a shift between the writes having 5 writes in one, or compressing all of the writes. Can you go into like some more detail about what that was?
Yeah. So that was for blob storage. And when we worked with Couchbase and had all these different things, so the static objects will be about 5 or so different objects. We have like console logs, response headers, response bodies, screenshots, something else, hard files, some other things I'm undoubtedly forgetting right now. Back when we ran on Couchbase, we would shove all these things individually into our data store. So we would store, like, for example, result ID, result ID screenshot, result ID response header. Now, we found that blob storage will bill you for the amount of individual writes that you do. So it made a lot more sense for us that when we generated a test result object, we would save these 7 or so disparate objects into one gzipped archive, and then shove the entire archive at once into blob storage, rather than shoving the 7 in and pulling the 7 individually out. And this saved us a bit of cost as far as running blob storage goes.
Cool. That seems like a great improvement.
Yeah. And in a similar vein, we did the same thing for call trees. Again, like a single call tree might have like upwards of like 100 different nodes. So as we like scraped Kafka, we tried to cache as many of the associated call tree nodes together in memory, and then shove them in. We might not always get like one perfect like write for every individual call tree. It might be 3 or 4 or 5 or 6, but 3, 4, 5, 6 beats 100 individual writes by far.
Definitely. I've got one last question for you. Is you mentioned your teams are one of the first teams within your company, LinkedIn, to actually start using Cosmos DB. Do you have any advice for newcomers to Cosmos DB on how to learn the service and start their apps, or maybe even considering a migration themselves?
Anybody's, yeah, definitely read over the documentation thoroughly. If I had, yeah, I mean, the partition key stuff was something in hindsight that, yeah, I mean, just looking through like use cases, looking through documentation would have been big. And one other thing that I would recommend is set up like a dev subscription. And the emulators are nice, but there's nothing that beats the actual thing, the live thing, for just playing around with it. When I was developing for all the stuff, I had my own an exact dev setup for test configs, results, call trees, and static objects. I used to just play with everything. So play with everything locally, very thoroughly before you shove it into prod.
Always good advice. Thank you so much, Robert.
My pleasure.
Thank you so much, Robert. Really great session. All right, up next. Oh, sorry. Go ahead, Deborah.
Oh yeah. I think we also wanted to plug. Just friendly reminder, keep the questions coming in. They're really awesome. You can also tag Azure Cosmos DB Conf with your social media, and we'll be responding there as well. For our next speaker, speaking of the emulator and local development, we've got Sean Wildermuth, who is a filmmaker, instructor, Microsoft MVP at Wilder Minds LLC. He will be talking about how to use the Cosmos DB emulator for development. Welcome, Sean.
Hey there. How are you doing today?
Good. Great to see you. Thanks for joining.
Great. Are we on?
You're on.
You're on.
Oh, Well, I'm glad everyone's here. I hope you're getting all your Cosmos DB info today. I'm going to be talking about more nuts and bolts about how to use the emulator for development. About me, you probably can see all this, or go to wildermuth.com. You'll see all the same information, so I won't belabor that. We only have about 25 minutes, so I'm going to try to be quick. For me, when I'm developing a Cosmos DB project, and I did this most recently with some nonprofits, and I wanted to be able to develop locally because I was going to be changing schemas a lot. I wanted to clear and rebuild data and all of that, and of course, not having to burn instance money while you're doing this is really helpful. And there's a tool called the Cosmos DB emulator, and it runs locally on your machine. It's not a replacement or like SQLite for Cosmos DB. It is missing a number of the features that you'll get from the full service, but for development, I haven't run into any limitations. It exposes a web interface for you to manage the instance, which I find really helpful. And then it runs on Windows natively. It's an installer, but it's also available on Linux and Mac as a container. And so let's get into the nuts and bolts of it. First of all, if you go to the documentation for installing the emulator, and I'll have a link to that a little later with a shorter link than this Docs Cosmos emulator, local emulator. This will walk you through getting the emulator and then how to run it. Let me just make this quiet. I always forget this last piece. Sorry about that, everyone. And it will talk about the differences and show you how to install it here. Of real importance is if you're working on Linux or Mac, it's going to walk you through how to actually do the emulator. There's a few different steps here that make it a little bit more difficult because the emulator doesn't run on Linux or Mac hardware, so you're going to be emulating, you're going to be running it in a container. So it may not be quite as easy to install for Mac and Linux. I hope they're working on that. I don't have any answers about that, but it is something that I think is really useful. And so when you have it running, it'll be here in the tray, and typically it will launch this UI when you start it up. I have had it running for days here now, so I'm going to actually open up, right-click the option here and open up the emulator. This just opens it up on a local port, and this is this home page of the emulator is going to tell you where it's installed. And so you can see there's a Mongo connection string, there's a primary connection string, and then URI or primary key, depending how you're connecting to it. So if we go here, and see this entire connection string, we can actually copy this directly into a Visual Studio instance. So I have a little web page here that shows some film information. And I have in app settings just connection strings. I can just paste that into the connection string. And you've seen a lot of code here, so I won't belabor it too much. But essentially, I'm using this connection string to connect to the Cosmos clients in C#, though this doesn't matter what platform you're working with. And so if we run this real quick, it should completely fail out. Let's see if it actually did that. Sorry about that. Let me just change the default browser. See if I can click on the wrong thing 6 times instead of 5 times. There we go. And so immediately I'm going to get an error in here. Well, I told you that there was this connection string, so we're connecting to it correctly. But the problem is if we come over here into Cosmos DB and click on the Explorer, there's no databases, there's no containers, and most importantly, there's no actual data here. And this makes it pretty easy. You could certainly do this through code, but I'm going to go ahead and create a new database. And this database I'm going to be calling L, which is some of the data I'm using. And you can specify some things. I'd leave it as default. And then within here, I can go ahead and create a new container for my data. So I'm going to use the existing one and just call this films. Now, you've heard a lot of people talk about the partition key and how important it is not to do cross-partition queries and such. My data set's fairly small, so I'm just going to use a partition key of year, which when we look at the data, you'll see how this is done. It's a collection of years that relate to the films that have been tested by the Bechtel test. And so now we have the films. Now, what do we actually do with them? If I click on the items, you'll see there's nothing really here, of course, because it's just a container. And this is one of the things I really like, is I can go ahead and upload an item directly from JSON. And I'll do that. Uploading this. And let's see what happens. Because I have objects, you'll see it said it created 44 objects. And let's tell it to refresh. Whoops. Why isn't it loading those? It said it created a number of them. Let's find out. I'm going to do the hard thing, and that is refresh the whole thing. There they are. And you see we have a key here, and if we click on it, we'll get that individual instance. So even though I sent it in as a collection or an array of objects, it's inserted it as individual objects that I can now actually call. And so let's go back to our Visual Studio. And let's restart this. Go clockwise to make it speed up. Still does not like it. Resource not found. What did you do wrong, Sean? I just ran through this demo too. Oh. I don't know why I had the wrong name in here for the container. Now we can see we have all this data directly from Cosmos DB, directly from the emulator, and not really that big a deal. You can see I'm using the SQL query, SQL syntax here. And one of the things I like about the emulator that is important to see is you can actually create your own queries. So let's create a new query, and it starts out with one that will work through the SQL API. And there's right now, it's only the SQL API that works in here for queries. We can see we're getting all of our data back. And we can go ahead and test out our SQL queries here as well. So, for example, if I just wanted to actually get the films, I could add into here, and let's say films. Join. Let me make this a little bigger so you guys can see it in the back. Join films on c.films. And here I'm going to say a value so that I'm getting a collection of those films. And let's see if I did this right. Try to get just the title. I believe that's it. That should work. Okay, let's find out why. on. In. How did none of you tell me I had put in instead of on? I don't know what to do with you guys. So here I have the collection, which is just the titles. If I remove this as films, I can go ahead and execute just to get the entire objects as well. Or I could even do all sorts of, much more complicated queries by using where clauses. And so, let's say, let's get all the films where C dot year equals 2013, which is the last year I have data for. So there were 99 in 2013, and we can see all the data to it. And notice we're getting the object back, not the object with all of its other data, because we're using value here. I'm sure a bunch of other speakers have talked about the query syntax, so I'll belabor it too much. Another one of the important ideas here is that you could certainly manage the Cosmos DB emulator here, but there's no real good add-in into Visual Studio to manage in. So I tend to do it all here. But you can that was the right one. You can in Visual Studio Code manage it as well. If you have the Azure extension added, you can actually add it from the databases. And so if you use the extension for Azure, let me just show you where to get that. It's called Azure Tools. Whoops. It is called, no. There's my filter installed. It's called, where is it? Azure Databases. So I have this installed so we can look at databases, and obviously Cosmos DB is one of them. And you can sign into Azure and look at the databases you have on your account, but if you're using the emulator and you look at this attached database account, you can actually attach the emulator. And it depends on which way you want to access it. I'm going to say core. And because it's on our local machine, it actually can find it right away. And in this way, you can actually look at the documents themselves as well. So here we can see each of these years' documents here without having to fight through and do things. And what's interesting here is, let's go to a document, and let's call this the Unflux 2 Boogaloo. Oops, too many quotes. And by making this change here in Visual Studio Code, it'll ask me, always upload this one, and I'm going to go ahead and upload it. And it's actually going to make that change. If we come back to the emulator and change this to 2005, execute the query, we'll see that that change was actually affected in the database server for us as well. I would never do this to a live database, but for the emulator, this can really help you tweak and change the kinds of data you're going to be dealing with, so that you have a sort of a well-known piece here, that you have your sample data that you're going to be running with maybe a small data set, so you can have that development experience be pretty quick. And that's why I think, the emulator, not only for that UI situation, but here in the SQL emulator for Azure, I just think it's great. I just really, it's a great way to get it into the project. And you can even import a document into the collection directly from here and not have to use the web UI at all. So it really depends on which way is going to be more comfortable for you. In the projects I've worked with, there's always been sort of this base set of objects we want to have inside. Some of it's lookup, some of it's other sorts of collections, but also the ability to very quickly set up your default collections that you're going to use in your development experience. And that becomes super easy either in the UI or here in the Azure database extension. So here, if we just put S as a new collection, and I say test ID, well, ID is an awful idea. Test region, start it with a default. This new test object appears. Of course, we don't have any documents. We can actually create documents directly from here as well as import it into a collection. And so if you're using Azure Cosmos DB and you want to use it in development without ever having to open up the Azure portal to create a default instance, this is a great way to handle that. Nope. And so any questions, and I'll show you some links that are going to be important to that. I think we're running a bit early. Ooh.
Hey, Sean.
Hey there. I always talk faster on these things than I expect to.
Thanks for walking us through the demo. I'll admit I was holding my breath there as you were refreshing that last browser page.
It happens to me every time. Luckily, I'm not spooked by it any longer.
We've all been there.
Yeah.
And that, you know, everyone watching on this call hopefully sees that I go through some of the same problems that you will at some point. And so, you know, I'm going to tell you that I did it on purpose so that it was a learning experience, but that would be a lie.
Yeah, I really loved your walkthrough of the emulator. So for folks watching at home, that is exactly how the portal looks like. That the UI that Sean was showing is exactly how the portal looks like today. So you can get started developing for free and just use that connection string that we provide and just test out your applications and see how Cosmos DB works before starting any other full subscription. And then once you're ready, you can move over to that.
Because it doesn't require you to even have signed up for Azure to start working with the Cosmos DB. So the entry point to just testing out some ideas before you commit to using Cosmos DB or any of that is pretty low. So that if you're prototyping something to talk your boss into it, this is a great way to get started without having to, you know, get into the more heavy things, even though, you know, it would be free, but it's a matter of there's a learning curve to the portal as well. And if you just want to start writing some code, this is a great way to do it.
Definitely. No Azure subscription, Azure account. All of our client SDKs are also open source on GitHub. So you can also just grab the latest drop of those, change the connection string, and get going.
Awesome.
Yeah, and I also liked how you showed the Azure Databases extension in VS Code, which is also a great tool for you to manage all of your Cosmos DB accounts or even your emulator resources on there. And you can just right-click, create a new account, or right-click, change different things directly from your VS Code, so you don't have to do too much context switching. And it's really convenient. What has been like your experience so far with that extension?
It's been great. I've mostly used it with the emulator, to be honest with you, but my experience with managing the couple of instances I have out there of Cosmos DB on my personal projects has been super smooth. Super smooth. The Humanitarian Toolbox project that I've been working with Cosmos for a while on, we mostly use the emulator, and then one of the folks that is managing the IT migrates the data up to Azure as we have new releases.
Cool.
Go
ahead, Deborah.
Please go ahead.
No, I just wanted to also add another thing on the emulator is that we also have a Linux emulator, which allows you to, we also have in that same link area that Sean mentioned, we have a section on how to use Linux emulator for Linux or Mac OS. And so you can also use that. And it also has UI as well.
Yeah, it's essentially the same that you install on Windows, but it's running in a container.
Exactly.
And there's a couple of things about signing access to it that they walk you through very, very carefully. I don't have a Mac or a Linux box easily near me, otherwise I would show that as well. But the experience once you have it installed is identical because it's the same code.
Yes, exactly. It's always great to see people using the Linux emulator. I'd say.
Definitely. So Sean, you mentioned you had a couple of other engagements where you're using Cosmos DB and you often start the development with the emulator. I was wondering if you could talk more about the development process and what kind of things you like to test there. What do you like to test in the actual prod environment, and how do you go about transitioning from the local environment to the cloud environment?
Sure. For me, I'm spending most of the time in the emulator testing the actual workflow of whatever the project is. So I'm not trying to. I think it's more important to see what I don't test in it, and that is problems of scale, performance. All of those aren't indicative of the cloud product, because the cloud product usually has more iron than we have on our dev boxes, especially since our dev boxes have many other things running at the same time. So I use it primarily for functional testing, so making sure that as we insert new objects, that queries work and that our unit tests against the local DB work. Directly unit testing that. Now, I'm typically in development as well, having the ability to wipe and recreate that database, usually through code, even though the emulator's there, because you're able to delete entire containers and even delete entire databases if you need to directly from the UI. And so that becomes a fairly low-hanging fruit. We can get this going. We can look at this, and in a lot of these cases, I'm using it in a mixed system where we do have Azure SQL or local SQL databases where we're using some data, and then we're using Cosmos for others. Because for me, using a document database has real world benefits when you're dealing with hierarchies instead of related tables. And so this isn't a replacement for SQL Azure. It's for me, it's an and, right? I'm going to use this and this. Maybe I do the top level searching in Cosmos DB, but then when I want to get, the complete list of sales or whatever, where I want a typical SQL Server instance somewhere, because I'm going to be doing data warehousing or reporting or other things that there's a lot more choices in the SQL space for. I hope that answered your question.
Yeah, that makes a lot of sense. I agree. Definitely +1 on mostly for functional testing.
Yeah.
By the way, for folks who are curious, even internally within Cosmos DB, when we build our client SDKs and add new functionality, we always test against the emulator as well in a lot of our own local development.
Yeah, and it's just you're burning less resources overall, and you're getting that same experience. Like, I've never run into this only works in the emulator and doesn't work in Cosmos DB or vice versa, except for some of the features that are listed in the documentation, most of which I don't run into. You'll find that in the emulator, you may get some false positives around performance of cross partition queries, because you're dealing with usually lower amounts. But I've been able to, in the instance, easily insert 1 million records and be able to query against it pretty quickly and all of that. So I'm pretty impressed with the emulator on the whole. It's not a proxy. I wouldn't be surprised if it's using the same code that the live service is using. But if it's not, it's an impressive copy.
That's awesome to hear.
Yeah, that's really great to hear. And then also for people who are, let's say, just trying out Cosmos DB and then they want to use the Linux emulator to get started, how easy is it for them to just go from, I have an small application running on the emulator to I now want to move on to Azure? How is that transition?
Really the difference between the two instances is changing your connection string. So you may have noticed in my example here that I have the connection string here in my development app settings in a .NET instance. Of course, this could be other things, because my expectation is when we go to deploy this or start using that, we're just going to change this. This is the development connection string, and then when we deploy this app to a container or wherever we're going to deploy this app in Azure, we're going to go ahead and set that actual Azure connection string, and nothing else changes, because the way you set up, the throttling and the scalability, etc., throwing more compute resources at it, that's all outside the context of this. That's all in setting up when you create your database. And in this case, when we go to production, just like we would with SQL, we're changing the connection string and going about our day. There isn't anything different between the two, or at least I haven't run into any.
Oh, cool. That's super easy to shift over from, local testing to maybe production environments.
Or even having a staging where you go against
or staging, exactly.
a staging live Azure hosted to see how that works, and then of course a third connection string for when you're actually going into production. And that's been typical because I usually have a smaller instance of Cosmos DB for the staging, because that's really just to run through more tests, make sure it works correctly with live, and then production, of course, will be sometimes a larger instance of Cosmos DB or a Cosmos DB with more compute resources.
Sounds good. Go ahead. We've got one question from the audience here. So folks, keep the questions coming. They're really awesome. Question is, how does Cosmos DB emulator handle or support user permissions?
I haven't run into that, and I don't think it does. The idea of tying it to user permissions isn't something I've ever done, and I don't think in the UI. Let's take a look. Where is Edge? There we go. I don't believe there is any place to put the idea of permissions at the item level or the row level in the UI here.
Would you like to show your screen here? Just what you're flunking around.
Oh. It says I'm sharing. Are you not seeing my screen?
Sounds good. No, looks good.
Okay, great. Sorry about that if it stopped.
No, that works.
Okay. And as I'm looking through this, I don't really see anything that is going to allow us to do user level permission. So I don't think so in the emulator unless I'm missing it, but it's certainly never come up in my case. Just make sure there isn't an option here now. I'm sure Scale won't allow us to do it. Yeah, I don't think there is going to be a way to do that here. And I haven't used it before. I've always used data inside of the documents to indicate who the user was, and I typically do the authentication outside of that. Certainly for cross clients or multi-tenant, you're going to want more protection against that. But I wish I had a better answer for you, honestly.
That's a fair point. I think go ahead, Steph. Sorry.
No. I was just going to mention that, this is about right. It doesn't support the user permissions because, as you mentioned, this is just an emulator of the service. Not all of the features that are supported in production today are supported in the Linux emulator. In the documentation, we do share some of the things that we don't support fully, but we do, exactly. We have a couple of differences on there.
And so this will walk you through what it doesn't support so that you can really see what the difference is. And this is directly in the link I have here. If you go to Sean link Cosmos DB-emulator, it'll take you directly to that page. So one of the interesting things for me has been that this emulator is an emulator for the SQL interface or the Mongo interface. And so regardless of how you're really using it, or if you're using those two instances at least, we've been able to test projects with it without really having to do anything but change connection strings. So it's kind of a fire and forget experience as far as I'm concerned. And what's I'll mention one other thing that I didn't show, and that is you can actually reset the entire emulator and start from scratch if that's really what you want to do, which is often helpful. Or even in my case, I can just delete the entire container. They're going to make sure that I know what I'm doing, and we can just start from scratch. And if you just want to get the itch scratched, you can actually start with a sample, and they'll create a sample DB with people in it that you can just start querying before you ever get to the point where you actually need to look at these things. And this is a great way to just like look at the API and see if that makes sense to you. These are really simple objects, but it's a nice, I don't have to think about or really rationalize about how partition queries work or any of that. Just get a thing here and I can start to look and see how, the SQL API or the Mongo API is different.
Yeah. All right. Thank you so much, Sean, for going over the emulator and some of the other desktop tooling that we have available. Really, really great session here.
Well, thank you very much. I hope everyone enjoyed it, and our next presenter will be very interesting, I'm sure.
Yes. Thank you. All right. So our next presenter, we have Kirk Marple, the CEO and founder of Unstruct Data, and they'll be talking about knowledge graphs from unstructured data.
Hi, thanks. I really appreciate being here. And what we're talking about today is going to be more of a solution architecture built on Cosmos DB. I have a long-time history in the .NET stack and kind of been using it since .NET 1.0 and started out with SQL Server, but then got into Cosmos before it was even called Cosmos. So using it when it was called DocumentDB. So happy to talk today. Let's see. So sharing. There we go. Perfect. So what we are, this is trying to keep the company part out of it a little bit more, but really what we're talking about today is enterprise knowledge graphs from unstructured data. What does that mean? So unstructured data to us means any type of media that is anything from video to audio to images, even documents and things like that. And so what we're trying to do for businesses is make sense of that kind of data, generate business insights, and leverage machine learning and sort of data architecture so that they can take their images from a drone, take documents, take Zoom recordings, and sort of trigger things in their business automation flow, remove a lot of manual operations, and as well give more access to exploring that data. It all comes back to sort of database indexes. How do you search this data and things like that? So obviously this is our opportunity we're attacking. There's just an amazing amount of unstructured data out there. It's being captured at huge levels. And really the issue we're trying to do is there isn't a service for this. There's things like Synapse for data warehousing on structured side. There's other companies that are in this space, but for the unstructured side, there really isn't a great approach other than a lot of times just writing code. Writing Python code, whipping together sort of DIY solutions and making it scale, and just having that semantic search for the indexing and aggregation is typically very difficult. And so what we've done, leveraging Cosmos DB, and I'll talk about all the other technologies on Azure, is we basically have a platform as a service deployed on Azure today that is many different managed services and code we've written, as well as different ML models and things that attempt to solve this problem for customers. And so really the goal is for a no-code, knowledge-based analytics platform. This is kind of what we do in terms of, be able to navigate the knowledge graph, which is actually driven off of the Gremlin API under the hood, as well as bring in any type of media into the system. And so really this is something for a whole wide variety of folks. It could be for data engineers to explore their data, prep data for machine learning training. It works well for just data analysts trying to make sense of the data that's been captured, and other line of business users. So unstructured data platform, we can basically take any type of data in. We can ingest from any cloud storage location. It could be OneDrive, it could be an Azure Blob container, an S3 bucket. And then the box in blue is essentially our architecture on Azure today. So we're using things like Azure Functions and event grid triggers for triggering file-based ingestion, metadata extraction. So all of this happens within an Azure function, so it's fully scalable, fully serverless. Metadata extraction could mean grabbing the image metadata, the EXIF metadata from images, and it could mean running ML. We're using cognitive services for like text for NLP on extracting documents. And then, but under the hood, the kind of bottom layer here is really the knowledge graph. And that is our data store. And it's something we came up with over the last couple of years, where it's a hybrid of a graph database, a kind of SQL JSON document database, and then a search index. And what I found, having the SQL background and starting to dabble in the graph world, there wasn't something that worked well as a hybrid. And so that's what I'm going to talk more about today. And so really all these nodes down here, these are the different sort of nodes in the graph that we extract. And we put a GraphQL API, which works great with a graph database. We put that on top of the system. And we're using a Hot Chocolate, which is an open source GraphQL library for .NET. If you haven't used it, it's awesome. And so that kind of drives the core query engine. And we use things like Gremlin API for graph resolvers. And so the graph is essentially the index to navigate the nodes in the graph. We use the document store, the kind of SQL API from Cosmos, kind of more for bulk load. So we generate IDs from the graph queries and then just kind of bulk load those objects as JSON and deserialize those back into our .NET 6 components. And so, but then the other half is, I mean, for things like driving the user interface and for analytics, you might want to do faceting. You might want to do full text search. And so we have cognitive search integrated into this, where those three kind of make a sort of triad of technologies that sit under our knowledge graph. And so when you go through a process of what we call entity extraction and generating entities in our graph, you're talking to all three at once. And so you're putting an index document into cognitive search, you're creating edges and nodes in the graph, vertices and edges in the graph, and you're putting the full JSON metadata into through the SQL API. And so on the outbound side, I mean, I won't go into this too much, but essentially you can drive other systems through alerts. You can do it through APIs, webhooks, all that kind of stuff. And then if you want to bring compute from the outside into our system, essentially you can enrich the data that's been brought in by other external APIs. So here's an example, and this is why a graph works really nicely for this, is say you have an image, say it was taken on an iPhone, there's metadata in the image that says, here's the GPS location, and it gives you, I mean, things about the lens that was used, the location, all these kind of things about the time. And so we pull that out, we store that actually through the Cosmos SQL. We then generate tags and what we call observations, which are kind of visual or perceived entities in the data. So we're perceiving that there's a boat there. I mean, we're perceiving that there's a sensor that's on that via computer vision. And so essentially what happens is these are generated in the graph. And then, but the value then becomes is, well, what if I've seen that same term in a document? I can now create this sensor tag. So I have one observation in the image, and the image is actually a node in the graph. One observation in this report, which is also a node in the graph. And then really then it's, we're connecting those two dots to a sensor tag. And so these green lines are literally edges in the Gremlin database. This can then even work for things like uploading a Zoom meeting where we're talking about sensor 17G, and we do text extraction via, say, Azure Video Analyzer for Media, and connect that as an observation from the audio. And so that's really the value of where the graph comes in, of generating the connections between the different entities. And so you typically go through this path of entity extraction, and then which is creating essentially the vertices in the graph, and then entity enrichment. And you're then sort of adding metadata to the nodes, you're creating more edges. And so we go through this kind of staged process. And this can be done manually as well. So through API or user interface, you can connect the dots essentially. But we try and automate as much as possible to make basically those connections and those semantic information exposed more easily for customers. Here's another example. So say, oh, that image didn't come in, but that is a solar panel. And so basically there's an equipment tag that was generated via, computer vision. And so we can basically think entity enrichment typically can happen via computer vision. It can happen by NLP, audio extraction. And this then lets people, think of the analytics you can then do by pivoting on, find me all the images that have that were tagged with a roof and a solar panel. And if you had to do that in SQL, it's a much more complicated schema. And so the nice thing about the graph is all we have to do are connect the dots between the edges and the nodes, and we can easily just pivot on any value in the database, in the graph. And that's something we leverage a lot. And if you're familiar with GraphQL, basically these are resolvers. And so we can say, for a tag, show me all the files. And that goes through a file resolver, that goes through the graph, the Gremlin API, and then can bring back a set of IDs that then we bulk load from Cosmos DB SQL and pump into the Hot Chocolate response. And so how's it done? So what we talk about is we're creating a graph of things. So you've heard of IoT, Internet of Things, and really we are extracting these entities from the real world. And that's really what we're focused on, is what you're looking at in the unstructured data, the images, the video, 3D point clouds, even in documents. It's really about the entities being discussed or perceived in the data. And so we're trying to extract nodes in the graph from that data. We're using all the other unstructured data that's in there, like GPS location and make and model of the camera, and we're analyzing that. And then the idea then is we can take those nodes in the graph and correlate them with structured data. Something we haven't done yet, but we plan to do is say connect to Synapse, Azure Synapse, and say, here is an entity in the graph. So let's, if we look back here, say this sensor tag exists in a structured database, and it is something that's in a data warehouse. We want to be able to automatically query across that boundary from our graph out to a data warehouse. And then what does this provide? It's really, if you've heard the term digital twin, it's a little bit in that realm. We're trying to provide the context between the real world and the digitally captured perceived world. And I worked in broadcast video for many years, and the video that is captured or generated there typically is consumed by eyeballs. That's really what it's all about. Gets out to Netflix or something like that. But here, the data is really consumed by machine learning algorithms. And so what we're trying to do is automate the process to get data into the hands of these algorithms, but also productionalize the value of the algorithms after they're run. Because a lot of times, people, there's so much commoditization happening in machine learning where there's a million models being generated. They're all, awesome for specific use cases. But what do you do with the idea that you found a conveyor belt? How do you hit a Teams alert, or how do you send an email summary of that? And that's really what we're trying to do, is leveraging that data and analytics to then get it back into the hands of other business users. Okay, I'm going to go through some of these are eye charts, so I've zoomed in on these slides, but we'll talk about the architecture and the data model, and so that'll be the second half of the talk. So what we have here on the left-hand side, and I know it's small, but I'll highlight it. So this is where the data is coming from. And so there's a user here going through a web browser. On the left-hand side here, there is basically a handler that is an Azure App Service handler. We're using the TUS protocol, which is a file upload protocol. And the blob trigger that we'll jump into here, it's a little small still, blob created trigger at the bottom. So that's an Azure function that handles saying, hey, there's a new file. The really nice thing about this is that scales really well. And so what we can do essentially is we get these event grid triggers that spin up blob created Azure function handlers. And so these sort of next boxes over are event grid. And so everything is driven off of event grid triggers to Azure functions. And then what we do is we convert that into what I'm calling a post, which essentially is a message on Event Hub. And so this basically puts a ton of messages, one for every file that's coming in. Say if you have 10,000 files on a blob container, it's very easy. It can generate these events very quickly in milliseconds, put them onto Event Hub, and then we're using Event Hub triggers into more Azure Function triggers. And so this works really nicely for an event-driven architecture where you can just dump any number of files in this and we automatically scale out. And then what happens is, so there's a process of entity extraction and enrichment where as we sense that the file is there, so we say, here's an image on a blob container, we pull that data back in, we do different things to it. We look at the metadata, we say, oh, it's an image. What things can we do to images? We have some built-in things that we do to extract that data. We say, okay, we're going to run a computer vision, like cognitive services algorithm on that to identify objects. But we also have made it very pluggable. So if you have models or pipelines that you want to drive against your data, you could say, hey, I have a model over on RoboFlow. I have a model that I built in Azure Custom Vision. We now have hooks that you can extend the enrichment architecture dynamically, basically at runtime. So let's see. So this basically what happens is we go through an indexing step, a processing step, and then a enrichment step. And so what happens is, if we go back here, there's sort of this middle area here that is the alerting, but everything ends up being what's called a entity command batch. And this is something I kind of created and invented for us, where it's a batched list of commands. Each command is essentially a CRUD type command. Create, upsert, delete. We have different things like some special operations in there as well for like caching. But the commands go through what we call a command processor, and that's where we talk to Cosmos DB. And so essentially everything, it goes through this command operation. And when we evaluate the command, we say, okay, I'm going to create an entity in the graph. In the knowledge graph. And so that talks to Gremlin. Well, it first talks to SQL API. It uploads essentially the JSON document for that entity. It creates the vertex. So there's a parallel graph and SQL with the same ID. We create the vertex, and then we create all the edges between that and other entities. And so maybe it's tags, it may be metadata as an entity connected to the file. We kind of connect all that up. And then we take basically the search index, which is another sort of parallel to that, and we can put in a special indexing document related to the entity. So we essentially copy some of the data over. It may be for full text indexing. I mean, we use it a lot for faceting, like for drop-down lists and things like that. And so that entity command ends up in 3 places: SQL, Gremlin, Cosmos DB SQL, Cosmos DB Gremlin, and Azure Cognitive Search. And then on top of that, we have basically a function app that uses Hot Chocolate to run queries and mutations. And so really what we built is a data loader in GraphQL parlance and resolvers and mutation base classes that just talk to the knowledge graph. And if it's a resolver, it goes through the Gremlin API. If it's a query, it mostly just basically goes through Cognitive Search. And so the nice thing about that is we essentially get Cognitive Search as a cache. And that ends up as a cache for very quick query. And then we basically can bulk load via the SQL API. And that all runs, it's actually we moved it over to an Azure function now. So it's all serverless as well. Okay. So here is another eye chart, but I'll dive into it. So the data model that we're creating, and this is really where, this is the enterprise knowledge graph as we see it. So there's the concept of files. So you have files that have what we call renditions, which are kind of, a file might be a sort of semantic idea. So it's an image of that boat that we looked at before. But we create a thumbnail of the file. We create a smaller version of it that is compatible with ML algorithms. But then we also have metadata that we extract. And so there's EXIF metadata, there's analysis metadata that might be more like, who is in, like you might see a celebrity or a person in the image. All of that is extracted. So we create these little trees in the graph that is files, renditions, and metadata. We can group files into sets. And then there's also the idea of a project, which is sort of like a folder concept where files can live in one or more sets, but files can only live in one project. So we basically have that those two areas. And then we have this idea of, let me actually, observables. I guess I missed that. Observables are kind of real world objects. And so this would be like a place, and it can also be a person or an organization. We use the schema.org schema kind of protocol for the basically mapping entities into the graph. So we try and schema.org drives JSON LD, which is a sort of common schema for knowledge graphs. So we try and canonicalize everything so that it maps to that, as well as add some of our own properties. And really, so we may see, especially from documents or audio or things like that, where it's spoken about a company. And so we would create an entity, an organization entity for that company. Same with a place. And then we could even import, say, like place hierarchies and things like that. And that could be from a geospatial database or some other database. And I missed the one slide here, but on the right, very top right is, we have this idea of an observation. And so an observation, think of it as something I'm perceiving in an image that's linked to an entity. So it's kind of an instance of a tag, or per se, or an instance of an organization. So you may have 10 observations of, say, a conveyor belt in an image across multiple images, but it's the same conveyor belt tag. And so if you think about it, that you essentially have edges from observations to tags. And so really, yeah, I mean, it's our whole entity extraction, entity enrichment model is basically to generate this kind of simple data model. It's canonicalized that then we can start running machine learning algorithms on this. We can do, obviously the schema goes up into GraphQL, so we can expose that to, it drives our user interface, but we're also going to be opening up our public API to this as well. So you can essentially load any data in, configure it with what algorithms you want to use for enrichment, and get really a nice clean GraphQL API from that data to search and navigate and things like that. And so really, I mean, how we did it, Azure Managed Services leveraged heavily. And so, I mean, I've been working in Azure for 5 or 6 years now, have tried pretty much, I mean, all of these and other services. This is really what we're built on. I mean, we do use some other external services for like video transcoding and other ML algorithms, but the back end is all pretty much Azure Functions, .NET 6 now, C#. So some of the benefits we had of, I mean, we're, not a huge company. I mean, we're just a startup that we don't want to be doing our own ops. I mean, so managed services are great for us. Having the ability to integrate easily with the SDKs, pay as only as we grow. I actually built a version of this on Service Fabric a few years ago, and realized just the cost savings by moving to Azure Functions was great, that I wouldn't have to keep a cluster, even just for demo or for test environments. Not having to keep a cluster live is a big benefit. I mean, there's a downside where, yeah, we can't run on-prem, but I mean, there are things that, I mean, maybe we could do in the future to kind of wrap this into maybe a Kubernetes architecture or something like that. But we really like the Azure Functions serverless architecture, and it really gives us really the ability to inherit all the Azure security and reliability features. And finally, yeah, I mean, I think the most unique part of this is leveraging kind of a hybrid index model. And I had kind of come up with it. I researched a bit, found some people had said, yeah, this isn't a bad idea to essentially use the Gremlin as the index, but the SQL API as the data loader. And it worked really nicely. I mean, we haven't had any problems with it. It scales really nicely. We use auto scaling in the Cosmos database to go, I think we're only probably going to like 4K or 10K RU max peaks right now. The most time, any bulk operations like bulk delete or bulk ingest are the things that hammer us hard. But in general, we're not getting hammered too hard by this architecture. It's really nice. And that is about it. And so myself, yeah, I mean, I'm on Twitter. The company's on Twitter. Yeah, if you have any questions, feel free, hit me on LinkedIn, and love to chat about what we're up to.
Thank you so much, Kirk.
Yeah, thank you.
It's also always awesome to see so many Azure services being put together, like and just working together to put something that's greater than the sum of its parts.
Yeah, we've definitely tried most everything, and so it's a little mix of everything. And it's, I mean, I'm a Microsoft alumni as well, so it was kind of in my blood to go the Azure direction, and it definitely has worked out well.
Yeah, I really like seeing all of those different Azure services working all together. Lastly, you mentioned how many RUs were you using for your service all
Yeah.
together?
Yeah, so
yeah, sorry, go ahead.
Oh, no, sorry. So, I mean, we're auto scaling up to, in some environments, 4,000, some into 10,000, but on average, we're still very low. But the burstability is great.
Yeah.
Like when we do like a bulk delete operation or some kind of bulk ingest, we can, peak up well, but then we're not paying for the rest of the day when that happens.
And is that across your both SQL and your Gremlin accounts?
Yeah, so I think right now we're set. I think in general, our default is 4,000 RU to the top for both accounts. But I think in demo and prod, we're at 10,000. We set it higher. So.
Yeah, it's always great to see good feedback on the auto scale and just being able to quickly scale up and down as needed.
No, it's been great, and I think it's. Functional. We haven't taken use of like some of the backup features or anything like that, but I think that's something we're going to probably have to do ourselves since we have to keep all the databases and the search engine in sync. But yeah, in terms of all the other functionality of Cosmos, it's been great.
I was wondering if you could talk a bit more about your experience combining kind of Cosmos DB and functions together to build this more serverless architecture.
Yeah, for sure. So basically everything we're using, everything kind of starts with basically a dependency injection service. And so we kind of have like a repository service that I built that is around Cosmos DB, and then there's a graph service that's similar. So everything kind of just driven by, and we're able to, it's nice because then we can test it directly. So we kind of build up these services. And then in the Azure function, we basically dependency inject a repository service and a graph service. And then essentially we're using a pretty common pattern of like having a type field in the document. And so we can basically have multiple object types, just it's in the same container. And then within Azure Functions, here's a good note of we were looking at using caching with the Azure Redis cache for Redis, and noticed that Cosmos was so fast; it was actually faster than Redis. And so, we were getting our queries back in, I don't know, just 10 milliseconds or something like that from Cosmos. And I was like, there's just no point, to even cache this somewhere else because it's actually faster than Redis. At least in our, we don't have a big Redis cluster, but I saw the question about the Cosmos databases. Right now they're generally small. They're in the tens or hundreds of gigabytes because we're just a metadata store. So the data in there, we're pointing to URLs on blob storage. So we're not keeping any of the raw unstructured data in Cosmos. It's really purely just a big index.
Makes sense. I think that pattern is actually quite common. We've actually seen it with a few presenters today, having a great metadata store indexing layer, Cosmos DB, and then a lot of the actual files and something like blob storage or something better equipped to handle those.
Yeah, it works. And that's where we essentially just, when we're processing, we're actually using durable functions as well and durable entities. And so we have things like a watch folder. So we spin up like a durable entity that kind of watches a folder and then wakes up every so often. And then that basically spits out messages back to, Event Hub. Yeah. And so then, but the nice thing is you get that buffering and that scale by processing Event Hub in Azure Functions. So. But everything runs back through this little command processor that I built. And that's where kind of all the federation into the different databases go.
Sounds great. Always great to see great architecture with Cosmos DB, Functions, Azure Event Grid, Event Hub, everything together.
Right on. No, we've been happy with it.
All right. Thanks so much, Kirk. Let's now move on to introduce our last and final speaker for this America session. Pleased to welcome Tadej Hakopian from Energy Vault, who is a program manager there. He'll be talking to us about information and visualization with digital twins for IoT. Welcome.
Thank you. Thanks, everyone. Getting started here. So yes, we'll be talking about information and visualization, digital twins with IoT, and what that looks like. It's kind of a little bit of a primer of what you can expect. So I'll get started. A little bit about me. I've worked a lot in technology in the physical environment, equipment, buildings, what have you, and trying to find a way to get the information out of the physical environment into this kind of digital format, either as a static, or I should say a discrete set, like an asset, like a 3D asset, or a dynamic set like reporting data. And it's always a challenge to get all the different parties together from different disciplines and different fields, and kind of have them speaking the same language about this new world of IoT and digital twins and how to make that real. So we'll talk a little bit about how all those pieces come to play. I've been through that rodeo a few times, and there's more rodeos to come since everything's kind of evolving field. And we'll start with the idea of like, what are digital twins? Because there's so many different definitions, I think. So I'll give
Hey, Fernando, so sorry to interrupt. You got to share your screen.
Yes, of course. My apologies. Share the screen. One moment, everybody. I will share my screen right now. So let me back up here to the what are digital twins portion. There we go. So title. Let's move forward to what are digital twins. And the textbook definition is a digital representation of a physical object or system. You receive input from sensors gathering data from a real-world counterpart. You simulate the physical object in real time and produces outputs that could be used for simulations based on the physical object. Sounds great. And usually the idea is like, it's very powerful. You usually hear the word powerful with digital twins. But, at the end of the day, it's taking some hardware and making a digital representation of it as electrons. That's all it really is, but you can do a lot with it. In this example, this robot arm is being manipulated by a user, and that manipulation is being replicated as a twin in a virtual space like I see in the big image. So that's usually pretty much what's happening with every digital twin. The information is being reported from hardware through a host to these visualization. That could be 100 different ways. The information visualization could happen, and you name it. In this case, we have both the visual animation and information referring to the actions of this arm in those numbers you see. So there's lots of use cases. There's a factory automation simulation, kind of like we saw in the last image, autonomous vehicle tracking, healthcare, using a device and monitoring battery. If you have a smartwatch like I do, that one is a digital twin of your heart rate, for example. That's reporting the very similar kind of concept. And structures and buildings, there's a ton of equipment in a given building, whether that's a building in the commercial space, industrial space, whatever, in your house, there's a ton of equipment running all the time in buildings. So the ingredients for a digital twin is IoT sensors, equipment, cloud, you need some kind of hosting platform, and data itself. So you bring these all together, and that's how you get the ingredients for a digital twin. And over the years, there's been a big scale up of these kind of services, cheaper hardware, easier to acquire cloud, and more ways to access data. So digital twins has really taken off. And there's a lot of benefits to it. Real time, look what's happening to your physical assets, so you don't have to guess or send somebody, to look at some hardware, equipment, anything into a space. You could just monitor remotely. Maintenance and metrics being reported to one place. You don't have to sort through papers and hard copies for this sort of thing, depending on the industry you work in. If you're a facility manager in the built environment, it used to be just paper, like actual binders of content to check information, which was always out of date in that case. And you can scale the operations from small to large projects. It's just a matter of expanding your project scope, and predict outcomes based on historical data from device data, so you can figure out if there's a maintenance requirement or maintenance case to be made. So you don't have to wait until something breaks. You could just get the information in real time. At the same time, prepare if there's a lifetime of the equipment's coming due, or there's some kind of inefficiency in the product. And you're wondering, okay, that's great, but what's in it for the end user or owner? The benefits is more data for ROI in the equipment, easier to figure out information, and easier to get support if you're an equipment manufacturer. Using our IoT devices, you can push out easier support for your users, your end users. And with all this in mind, I want to talk about real quick data standards, our favorite subject. There are a lot of, just about any industry, there's a lot of different ways of explaining how something should be. The primary use case, schemas, digital twins and IoT is no different. There's a lot of different schemas and standards. So that's been a thing over the years. As you can see in this cartoon, usually what happens is you put one more into the bucket and people are even more confused. That's kind of what happened to digital twin and what they call Industry 4.0, things like that. They had this big set of digital twin consortiums and different standards released by different industry groups and different working groups that made sense for maybe a specific use case, like different kinds of devices, different kinds of machines, different kinds of whatever. And so it's been a little bit scattered. However, the good news is you got the Digital Twin Consortium. This is a great reference to figure out the schema and terminology and definitions you could use to align everybody in a project scope. And the reason I bring this up is you might be working on, like, for example, the data side of things, DevOps side of things, cloud side of things. But if you're trying to actually implement something like this for a more comprehensive project, where you're bringing in people who may have no idea what you're talking about in any of these technology spaces, having this kind of reference, it's like, this is how it's done in the industry, goes a long way, because you can always send them, say, this is your document, this is your reference. So if you say, what's computational representation? You can say, where are what's the function of the inputs and outputs? You can give them some kind of document like this from Digital Twins Consortium, which explains, what happens with computational needs in digital twins. So you could say the reference data goes through an algorithm based on inputs that creates an output. Is this into the kernel of the actual operation? No, but it gives you a schema to follow, which is very valuable when you're trying to explain to people what it is you need to even get started. Same with stored representation. Okay, what's structured information? It could be GIS, it could be IoT streams, databases, building information models, you name it. So this is what that is. I always make a point about this because it's so critical to have standards and common language when you have so many different streams of, you have the guy who's been facility manager for 20 years who may need your digital twin, the guy who understands the hardware portion of it very well, but not the software. You have the person who's, maybe the program manager on behalf of somebody, but doesn't understand the technology side. You can say, these are your common standards. So it's very helpful to have these kind of tools. And so digital twin is something I recommend. As long as you're not using Excel as a database, that will take you far. But it's always good to make sure you're all in alignment. I cannot emphasize enough alignment with everything. We'll talk more about that. So that's standards. And then we got tech stacks, which is even more fun. The ideal situation is you have something that kind of takes all the inputs and transforms it to all the outputs. That's not so easy in digital twin world. There's some better solutions over the years we'll talk about. Basically, you have a bazillion different kinds of inputs from different devices, and you have a bazillion different kinds of ways to report that. To simplify it, we have smart devices, which are the equipment, machines, monitoring, tracking, telemetry, phones, whatever you name it, that can then go reported to network gateways. Okay, this is the next step. You need some kind of Wi-Fi or Bluetooth or what have you to actually take the device data and transfer it to the middleware, which does the cloud storage, the network management, the hosting, and everything that can then finally be used for applications, which is the meat of it. That's where people want to get the information and data from, eventually visualizations as well. So it's quite a different number of steps here, and this is just a basic schema of that. And there's a ton of different providers, whether it's the any kind of device side, graphic engines, cloud services like Azure, and you name it. There's a ton of different providers, and part of this issue is how do you bring them all together, because these might all come into play and say working in buildings or with a lot of data embedded into it, working with equipment manufacturers like Samsung, like Apple. They all have a ton of data into them, and then you have to find ways to connect all these different streams depending on your project. And of course, with that data, you have to find ways to present it, and you have a bazillion different options from different open source solutions like Python, like Pandas, but also things like cloud support, like Azure and AWS and all the others. So there's a lot of different ways to then take that data and work with it. So this has been the kind of challenge over the years: is how do you take all these equipment information, work with all these different suppliers and vendors, put it together, and then also find a way to transform that data. But to keep it simple, all we're going to focus on is sensors in the real world, some kind of model representation, some kind of digital model representation, and hosting. The servers that connect the sensors and models to other endpoints. And with hosting, what's great is you have Azure Digital IoT. And what's really great about that is it does what you want to do. It takes a lot of the sources, different sources of the information, and transfers them to different handlers, for example, in this diagram. But you could take it further, and just like the diagram I showed you prior, it has a full spectrum solution with Azure Cosmos and IoT. So between the hardware, the things, you can then transfer to a gateway hub, and then from there, it goes to hosting and data platforms, which from there you can create applications, just like we saw earlier in this slide series. So it's all there, and I have a link to the bottom there if you want to learn more. So it's great that we can see these kind of integrations and meshes of data instead of having to kind of jerry-rig it ourselves. It's becoming a lot more consolidated. So there's a lot of opportunity to create these kind of integrated workflows with these backbones, like Azure. And we'll talk about next about hardware, to get a sense of what the hardware environment looks like after we talk about hosting. So usually we have these kind of situations in hardware. You have the built environment, and you have the data you want to get out of it, information. And so you have to put them together into some kind of application. But usually you have to start first with the actual equipment, and the equipment is, in this example, an apartment, it could be your appliances, your phones, your keys, your security monitors, you name it. There's a ton of equipment in the average apartment that is already enabled for gateways for IoT and smart homes. And that could be as simple as well as a custom-made Arduino board that can use open source tools to connect the information to the gateways. So there's 100 different ways you can connect hardware to the built environment. In this example, this is just a little board that you can put onto the back of a wall. In this case, they're using these for modular construction for homeless projects in homeless housing projects in Los Angeles. There's one example what you can do with IoT devices. You can make 100 of these very quickly, pin them onto a board, and then they'll just report data about whatever you need to report data on, whether it's occupancy sensors, heat, equipment. It's all there. So this is what the actual hardware can look like in the built environment that might be all around you in a given facility that you're sitting in maybe right now. And it could be huge. This is the Deer board plant by Ford that uses these huge 3D assets these huge assets in 3D of industrial equipment. And that they mapped all this out to their own digital twin. This is a 3D example and visualization of that. So they can monitor it remotely without having to necessarily be there. They know what everything's in there, what it looks like, the information they're in. So it could be from a tiny scale to a huge scale. It's all depending on the need of the project. It's all doable. So with all that in mind, we talk about visualizations. And what's really great about visualizations is it's very intuitive. Visualizations has a lot of ease of access to the average person, whereas the backend stuff of the hosting and the hardware might be for specialists. Anybody can get a lot out of visual tools and how they can see the environment in VR or into a application. So in this example, this is kind of a little comic here, but people love putting on those goggles, just seeing the world for themselves, stepping into it. And there's a lot of applications you could use. So you can imagine taking all that data we got, all those 3D assets that we have, and connecting it to an environment that you can easily look at in 3D. So what does it look like? It could look like 3D models, just basic geometry on your screen. It could look like charts, just information charts. That's another way to visualize your environment from a digital twin. It could be VR, immersive. And it could be maps, like laying out the map and environment to see where everything is. So we'll look at some examples of all that. In this case, we have this example of using a 3D space of a building and checking data over a series of time in 3D. This is very intuitive. People can see their building, the layout changes over time, and they can track the progress. I talk about the average user at the end of the day. This is the kind of thing that all the applications come together can benefit from, is this kind of easy to use UI. And it can get even more immersive. You can do something like in this example, using the same tool. This is a Autodesk tool that does 3D visualization. In this case, we're seeing temperature with the highs in yellow, lows in blue in this office space. This is a user can navigate this space, look at what's going on very easily. These are all based on actual telemetry sensors of data in this space. So if anybody's curious what's going on in the office, let's say the office administrator is trying to figure out what the temperature is, people are comfortable in the office, they can pull something like this up and look around. So this is the benefit of the visualization. You don't have to be a wizard at any of the technology or backend, it's all just there, easy to see, clean, nice little heat map we have here. So this is very intuitive and people can navigate it very quickly. And then you also talk about the VR space, how people can do something like this, which is using equipment in real time that is then tied together with a VR headset, so people can be trained remotely on hardware equipment that might be somewhere else. That way, you can train people to use just about anything, anywhere, with some headsets and some connection to the actual equipment. They can click through it. They could look at all the handles and nozzles and all that stuff. So this is a case of real-time interaction. It's not static. It's like, it's happening. So this is another example of how that digital twin can be useful in applications of training. And that could be including surgery, for example, doing some surgery on a dummy remotely if you can't be there in person, or at least monitoring the surgery in real time if you can't be there. And we talk about, maps and layouts. In this case, it's a simple map of a floor plan of a building. And we're getting just some occupancy data, looking at this solution here, which will look at a floor plan, see the kind of information, whether it's humidity, temperature, comfort zone, really quickly checking it out. In this case, it's a lot more bread and butter example, easy to read for anybody who knows how to read a floor plan, and get a lot of data out of it, again, in real time, look at it in your app based on real-time updates. Or inventory. In this case, this solution right here uses a inventory of all the 3D assets already programmed. This is an example of how you can use what they call a building information model, a BIM model, to say, okay, like I already created your entire asset of, say, an office building, or in this case, a hospital, into a model. And in that model, you have every single asset in your hospital: beds, every kind of door, every kind of chair, sofas, you name it. It's all in the project. So if it's already designed like this, and it's already in this discrete database of a BIM model, I can then give you an inventory of all the equipment you'll ever have in this building, at least on the turnkey basis. And then you can hook it up into an inventory tracking system, again, through a digital twin, that can then keep catalogs of all the equipment. And you can sort it out nicely into a given type of equipment, like doors, chairs, you name it, so it's easy to track. And you can tag the warranty information and everything in here. And over time, you can update it with changes, new purchases, new orders. This is another way to describe that data for somebody in that world of maintaining space. You can even go full bore into the game space and use something like the Unreal Engine paired with, say, an Azure backend, and using different kinds of 3D assets, whether it's from, say, 3ds Max, BIM models, you name it, and create a real world environment. This is a project from China showing how you can use Unreal Engine with all these different tools, the 3D world, the sensors and the hardware and the backend hosting, to create an immersive world that somebody could see what their industrial equipment looks like. It can go anywhere from very straightforward solutions that are provided to you by a vendor to these customized kind of solutions where you can build them ground up. And you can go from the campus building scale to a huge city scale. This is Helsinki. They're doing a digital twin project of their entire city, starting with some of their business neighborhoods. And in this case, this is the urban scale. This is the geographic information systems paired with the city databases, paired with information from different sensors that they can report, much bigger scale, much more comprehensive data, because you can go into the buildings, you can go to the streets, you can go to geography, the weather, it's all there. So you can get really big with digital twins. It's all a matter of how you develop it. And it's, again, a matter of how you structure it so people can work with you on these bigger projects. But it can start from a very small premise, like a room in a building, to something this big, to give you a sense of what's possible on the visualization scope. So talk a little about planning with the last couple of minutes. Who pays for all this? The owner of the project pays for all this. It's not necessarily inexpensive. It just depends on how ambitious you are. Okay, so the business case has to be justified as, like, proposal. Is this a valid proposal to get these kind of IoT digital twin services included the way we talked about it? Can you set up a pilot project so that you could have a low cost or no cost way of testing out? Maybe it's the right solution, whether it's for equipment, vehicles, building, you name it. Is it the right solution? Let's do a pilot project, test it out, test the waters, see what works. Maybe your client would like this solution to be implemented. What's the ROI? Consider what the potential savings are when you have a way to report real-time information about equipment and sensors that could tell you if there's something that's going to be breaking down, if something needs maintenance, or just tracking inventory or tracking people's comfort in the space or their experience using some equipment. What is the ROI? What's the amount of time you save doing that? What's the potential time and equipment savings? And look for opportunities. Maybe you have to ask around. Maybe you have to prod a few people and see, hey, what can we do here? Is there an option to use a hosting solution in this project, use some equipment, whether it's Arduino boards or something a lot more robust? Look for the options and opportunities available to you. And always better to, when it comes to adoption, start early in these kind of cases. Again, this is a learning curve. You're never going to figure out the first time. It's going to be a lot of stakeholders over a long period of time to make these kind of digital twin projects possible. So you want to avoid trying to catch up when this becomes very commonplace. I've been in situations where technology in a given industry, let's say healthcare is our standard, kind of like a whipping boy for laggards, might be taking a while to adopt, but once they adopt it, they really want it, and it goes from 0 to 60 quick. Instead of, like, they give you the same old kind of expectations of what they want for a project scope that you might have worked on with these kind of clients and owners. They get religion really quickly, and they're like, you know what, we want this now. And they're like, oh, wow. And you have to jump on it. So try to be as progressive as possible so you don't end up in a curve of like, oh, we've never done this before, never to scale. Always try to be working with the early adoption curve. Look for those opportunities so you don't end up being a laggard where it's challenging to adjust, where you have these huge project requirements and you're not sure where to start because there's so many different stakeholders depending on who you are working with. And just kind of a quick cycle on the project team setup. You want to assess the circumstances of the project, plan it out, document what's needed, train people, and this could be executives, VPs of whoever you're working with, whether they're procurement side, operations, even in your own technology team internally. It doesn't hurt to train them because I guarantee you nobody's going to know every facet of how a digital twin works in one way or another. Maybe very savvy on the cloud side of things, but not so much on equipment or operations. Training goes a long way. It could be a simple, primer. Common data environment, CDE, what is that going to look like? Is it going to be a 0? Is it going to be something else? Figure out what that's going to look like. And then get the cloud host, analyze the data, study the trends from your data, your historical information, get valuable insights, update your operations, and repeat forever. Easy. And I would love to show you an example from work, but I can't. But suffice to say, we are using some digital twin solutions ourselves. We are using a 0, and it kind of looks like something like this on the ontology models. And so we're plugging away to get some work done ourselves to connect our devices to a cloud host, to do an analysis, to eventually get some useful information, whether it's information for operations, purchasing, logistics, you name it. This is the kind of things we're looking at ourselves. And what's great about 0 is they give you a full platform to do just about everything I've just talked about. And I think it's the way things are trending over the coming years and months, or I should say years. But it's accelerating. So look at these solutions. Look at what kind of needs you want. This talk is emphasizing the big picture things because, again, you're never going to know every single part of this. So it's great to have a strategy, have a roadmap, have a plan, have some ideas out there of what you want to achieve, what you could be solving problems for. Because this is a huge growing demand for digital twins in the whole built world. And to get started, if you want to figure out how to plan for your digital twins in 4 easy steps, know what you want, what kind of things you care about, look for the opportunities, what do you want to achieve, plan it out, figure out what you want to do and how to connect it together, figure out your gaps, and adjust your operations in case they go off course, because they usually do go off course. And figure out what you want to achieve. Do you want building performance or equipment performance? Do you want user feedback about some equipment they're using? Do you want to do more automation and less service for equipment? And bring it all together. We're creating connections to the physical environment, get live updates for physical equipment, have a place to store the data, analyze the data, update the equipment, digital assets, repeat forever, just like the real world. The ride never ends. And takeaways, I'll breeze through these. What we talked about in a nutshell, physical assets connect to digital assets via digital twins, standardizing bodies, providing the common ground for digital twin strategy. There are lots of different options. Figure out the one that best fits you, test them out, and find opportunities to try out digital twins. here are some references. Also, will be in the video notes for this event. And thank you so much for your time here. It was a pleasure speaking as your Cosmos DB. I hope you all got something out of this talk. Please contact me if you have any questions. I don't think we have time for Q&A, but I'm always happy to talk with anybody about these kind of topics.
Thank you, Tade. Thanks for the great explanation, introduction to digital twins and IoT. It's really awesome to see just even more broadly how far technology is progressing, and just seeing that robot arm in real life versus the thing it's wild.
Yeah, same here. I had a really great thoughts on that. You mentioned like that there was like a trifecta of an IoT like sensor that emits some data, and then you need the store or some like database storage. In this case, you guys are using like Cosmos DB is what I heard at the last couple of minutes. How is Cosmos DB doing in terms of like latencies, and I know throughput and write heavy workloads, that kind of thing?
Well, currently we're at the early stages, kind of like we're at our own little pilot program. So it's a very base level kind of latency, but we're trying to see if we can scale it up to like thousands of updates a second for some of the equipment we're testing out. So it's we're starting out at a very basic point. That whole earlier stage I was referring to, where we're assessing and trying to bring things together and figure out stakeholders and exactly what we need, and then we're with the Azure tools we're using, we're trying to lay that groundwork so that we can aggressively push that kind of reporting. So to much more intense. So we feel pretty confident with the Azure tools we're using, and it's been working out both ways. It's been working out pretty well, and we're pretty excited about the things Cosmos and digital twins and IoTs being put together with Azure. It's one of the reasons we are using Azure for some of our project operations. So it definitely scales up pretty nicely in the long term, because depending on what you're doing, it can be some intense data reporting that might not be for everybody, but it's something we're looking at.
Thank you so much, Tade, and thanks for joining us on Cosmos Conf today. I guess it's been really great to see just over the past 3 hours, the variety, the diversity of projects, applications that have been built on Cosmos DB, everything from applications for a pharmacy to things to help patients with diabetes to IoT. Steph, any closing thoughts you want to share, just general observations?
Yeah, I actually had a lot of fun learning from people who use Cosmos DB on a day-to-day basis, and the cool things that they're using and Cosmos DB for, especially a lot of the graph sessions. I really had a lot of fun learning more about that, and the desktop tooling space, that was also really great to see good feedback on that. Overall, I really enjoyed all of these sessions. And yeah, any other thoughts you wanted to share, Deborah?
No, echo. Thank you so much to all of our customers, users, developers for all your feedback and support. We're building the product for you. So excited to spend this time with you today.
Yeah. Great. And so before we sign out, we want to leave you with a couple of resources and a few helpful links for you guys. So there are basically 17 on-demand sessions for the Azure Cosmos DB conference. And all of these sessions, if you ever miss any of them, you can find them on aka.ms/Azure Cosmos DB. Azure DB Conf. And if you want to learn more about Cosmos DB, we have wonderful host Mark Brown. He hosts Azure Cosmos DB Live TV with members of the product group, Cosmos DB community, and you can catch a bunch of those different episodes where we talk about new features or just new projects that we're working on. So you can catch all of those episodes on aka.ms/Cosmos DB Live TV. And also, if you're new to Cosmos DB and you want to try it out for free just to get your hands dirty, we do have a blog post on different ways that you can try Cosmos DB for free. So you can find that at aka.ms/Cosmos DB-free. And lastly, we also have a couple other sessions in other time zone. The next one is Asia Pacific time zone, and we'll be starting in about 8 hours. So that's 8 p.m. Pacific time, 11 p.m. Eastern time. And yeah, thank you all so much for joining. I had a great time.
Thanks, everyone.